South Africa, a country where necessities are a challenge and reality in poor communities. Awqaf SA is on a drive to make a positive change in people's lives. Our work is deeply rooted in the ethos, history and belief of our religion. Through your Waqf donations, we are building a brighter future for education, healthcare and infrastructure, and fulfill a sunnah in paving a way towards a brighter tomorrow. With your support, Awqaf SA has the power to transform lives for generations to come. Donate today and build a foundation for a brighter tomorrow. Awqaf SA, creating an eternal legacy of hope and dignity.
State Cape Town. We will be going through Maths Paper 2. Mr. Khota dealt with Maths Paper 1, so you can log on to our YouTube platform to access that. This is a very important workshop. It's going to assist learners with their preparation for the June examination. And as we know, that grade 11 is a very important year for them. It's a gateway to grade 12 and for the rest of the future. So please hit us up in the comments. Let us know where and from which school you are connecting to us from. Pose your questions and Mr. Khota can sort it out during the course of the session. Awqaf has been hosting these workshops since 2016 to assist learners across South Africa improve their maths marks. Last year, our top performer, our grade 12 performers scored 98% in mathematics. So you too can level up and you can perform and achieve your best. So we are also live streaming this via TikTok at Awqaf SA. Please join that platform. I think it's a very important platform. We are live streaming via that platform. So that's enough speaking from my side. Mr. Khota will be doing most of that today. And to cue in Mr. Khota, we're just going to play his little launch sequence video. If you can cue that for us, Sami.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff. Liftoff. 30 minutes after the hour.
And lift off. How's a round of applause there, Mr. Khota, for yourself? for
Morning,
waking
good
up
morning,
early?
good morning. How are you, grade 11?
Yeah.
Welcome, Cape Town. Welcome, SP learners, the learners from, I see we had some learners here from Kurtuba online as well. We got learners from across the country all coming in. We've got all our onliners in. We got McDonald's in. We got Giga in. Abdurrahman in. Yumna in. Mike in. Muaz wasn't dreaming about maths last night. Nomvi, and welcome to everybody. Guys, I hope you guys are nice and fresh for this morning. We've got a bumper session and nothing like, I know some of you brought some coffee, but nothing like some warm, hot, fresh, higher order algebra to wake you up. How about that? How about that, guys? How about that? So I'm going to start off with a question here that I came across. I was just going through, you know, I finished off with this. I was sitting last night. I was having supper and I said, let me see if there's anything interesting that we could come across. And before we get into, I said we're going to do that functions application this morning. And then we are going into paper 2, analytics and trigonometry and Euclidean. I just want to start you off and warm you up with this question. So take this one down. The one that I came across. Good morning, South Africa.
What's
3
required,
to the power
Mr. Khota?
2017 all over 60 into the cube root of 3 to the power 6048. 3 to the power 604. Warm, toasty algebra question for you to warm you up and get your engines running. Welcome, Cape Town. Welcome, Cape Town, the mother city. Leila Bawa, hello. Nabila is in. Laiba is in. Muiz is in. Yuvan is in. Rocky is back in the house. Hello, 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 guys. Good morning, good morning, good morning. So let's get started with this. If you had to see something, so big shout out to his friend Wade. That comes from Yusuf Adams. And they say they're not having any sound. Let's check.
Okay, we'll have a look at that. We'll have a look at that.
Okay. Are we all good, guys? There's sound. There's sound.
Okay.
There we good. We good. We good. Tala Sayed. Hi. How you doing? Hit us up from where you coming in. Chicken noodle soup. Hit us up from which area you are coming in from across the country and tuning in from. Giga, my man. Let's quickly kick that one out. Right, where do we begin here? Come on, grade 11s, we need to simplify. Obviously, we can't use the calculator here. So if it's without the use of a calculator, where would we begin? We got two terms separated by a positive or negative sign. So what would we do? Highest common factor, of course. So it's 3 to the power 2017 into 3 to the power 21 minus 17 is how much? 4 minus 3 to the 2017. You took out 3 to the 2017. What are you left with? 1. All over. All over. We got 60 there. That's a 60 into 3 to the power. Now, inside, to remove a third sign, inside power divided by outside root. So it's 6048 divided by 3. Let's go to our calculators. Let's go to our calculators. 6048 divided by 3. I get 2016. 2016. There we go, onliners. I hope you got that. How's our tech team doing there at the back? How are you, Nasir? All good there, my bro? Hello, Munazza. Roshni Secondary School, Muaz Khan coming in. Munazza all the way from Johannesburg. Guys, let us know from which area, from which province you also tuning in from. Now, what do? We divide. Now, remember, we're multiplying and dividing. So it's 3 to the power 2017. We're dividing and bases are the same. What do I do to the powers, guys? Subtract. Your minds are nice and fresh early in the morning. Let's get this done. 2017 minus 2016 into 3 to the power 4 is 81 minus 1 all over 60. This is 3 to the power. 2017 divided by 2016 is how much? 1 into 81 minus 1 is how much? 80 over 60. There we go. We see that we're getting somewhere. We see that we're getting somewhere, guys. Let's simplify. 3 goes into 3 once. 3 goes into 60 how many times? 20 times. What's your final answer? 80 divided by 20 is how much? 4. And there we go. Your answer for that one is 4. This is straight out of a past paper. This is straight out of a past paper. We're going to do 2 more just to get it all heated up. Then we're going to go into that functions. I've screenshotted some from past papers. We're actually going to work through it now. Hopefully, we're going to get full marks. All the systems that I showed you yesterday, all the systems that I showed you yesterday will be applied to the next batch of questions that I will be asking. Onliners, welcome. We got Lenasia Secondary School. Muiz is in there. Tala Sayed from KZN. Giga says he's from Australia but tuning in from Northwest. Nice. Beautiful. I hope you all took this one down. Guys, you need to learn the system. All we have to do is without the use of a calculator. So it means that a lot of stuff need to cancel each other out. Usually factorization comes into play. Okay. The next question, and I'm sure you all can do this one. Again, like I said, this is just to warm up your algebra engines. Let's all do this together. 4 times 3 to the x minus 3 to the power x minus 2 plus 3 to the power x is equal to 44 over 3. For 6 marks, solve for x. For 6 marks, solve for x. Let's get the mic in the pocket here. Here we go. That's all good. Okay, brilliant. Lift off there. Start it. Don't wait for me. Solve for x. The question doesn't say simplify. It's got an equal to sign, so it's an equation. Solve for x. Learn this. And the next one, like I said, these questions are just here to warm you up. The next one is a solid algebra question, higher order. It's gonna rock your brain. Might rock somebody's brain. It might pain someone's brain. Onliners, Springs Muslim School, Fatima Patel, welcome, welcome, welcome. RIS in the house. Morning, Giga. Gauteng Akudo College. Okay, never heard of that school. Nice, nice, nice. Get all your friends to join in today, guys. Remember, we're going to rock trigonometry, we're going to rock analytics, and we're going to rock Euclidean. I'm sure you must be all done with this already. No? Break it. What is the rule for this? What are the rules? We got to, step number 1, we got to break it all up. Break up. Divorce. Talak. We break them all up. Then we take out the highest common factor. Then we get rid of the brackets. Then we solve for x. So it's done in these 4 steps. It's done. Here's the rules for this type of a problem. So this is 4 times 3 to the x minus. So we're doing the first one. We're breaking it up. 3 to the x times 3 to the minus 2 plus 3 to the x equals 44 over 3. Do not use decimals because it's without the use of a calculator. Right, grade 11s? Are we all on the same page? Can I put a tick there? Are we okay? What's the second step, guys? Highest common factor. So I got 3 terms separated by a positive or a negative. What's your highest common factor? Don't tell me 3. 3 to the x. Very good. So that's out, that's out, that's out. What's left over? What's left over? 4 minus 3 to the minus 2 plus 3 to the x divided by 3 to the x is how much? 1 is equal to 44 over 3. Yes or no? Now let's get rid of the brackets, guys. Let's get rid of the brackets. So we got 3 to the x into. Now, here you can sort of cheat. Use a calculator, but no decimals. Go 4 minus 3 to the power negative 2 plus 1. As long as you don't use decimals, you're good. 44 over 9. All this here will give me 44 over 9 is equal to 44 over 3. Now, we need to get rid of the brackets. How do you get rid of 44 over 9? We only want 3 to the x on the side. So you either divide by 44 over 9 or you multiply it by 9 over 44 by its reciprocal, by its opposite. Why? So that 9 and 9 can cancel, 44 and 44 can cancel. What I do to the left, I do to the right. I'll put a tick there. We're all good there. Now what am I left with? 3 to the x is equal to 44 and 44 will cancel. 9 divided by 3 is 3 to the 1. 3 and 3 cancels. What is x equal to, guys? X is equal to 1. How many marks did we just score? 6 marks. We just scored 6 marks. You need to learn this. They love this. So whether you see it in the June, whether you see it in your class test, or you see it in the final, but you are going to see a question like this. So learn the template. Learn the template, learn the style. Fidelitas Comprehensive Schools. Welcome, welcome, welcome. Moa says x equal 1. Well done. Lawrence from Krugersdorp. Well done. Welcome, welcome. Karabo, good morning. Yes, Laik. Does this go with the impact syllabus? Of course. The impact syllabus is caps. Remember our program here. What we are doing now, whether you are DBE, Department of Basic Education, Impact and all these homeschooling and distance learning, you guys use Sakai, South African Comprehensive Assessment Institute. It's all, you all write the same cap syllabus. They are all caps. And if you are IEB, it makes no difference. So this course is for DBE learners, Sakai learners, as well as IEB learners. Remember, DBE is your normal government schools. Sakai is for distance learners and homeschoolers. IEB is your X-Model C private schools, independent examination board. But you all do CAPS. It's the CAPS is the national curriculum. So this course, as long as you are doing CAPS, as long as you are in South Africa and you're not doing the Oxford or Cambridge, that there are certain other topics. But this is still, even if you're doing Oxford or Cambridge, this is still asked in Oxford and Cambridge as well. As long as you're grade 11 learner, this work is for you. Okay, now let's give you that last one. Let's give you that last one. Just to warm, and this is the last algebra question I'm giving you for today. Solve for x without the use of a calculator. X to the power x is equal to 2 to the power 2048. No calculator. Come on, grade 11s. Apply your mind. I know this is a killer question. It's the last higher order question from all your algebra. This is going to determine whether you're going to get 100% or you might, for algebra, maybe out of 30 marks, you might get 30 out of 30 or 26 out of 30 or 25. It's worth 4 to 5 marks. This will determine whether you are 75%er or whether you are 100%er for algebra. It's the last question from this paper. Come guys. Come guys. Come onliners as well. Crack it. Crack it. Let's see what you're going to do with this. I know you've never seen it before. Trust me. Many learners in the country have never seen this before. But it's out of a KwaZulu-Natal grade 11 paper, June exam. This question comes out of KZN. I think it's 2024. KZN June. Grade 11. It's not a grade 12 question. The district set it. The department set this question. I'm not sucking thumb here. Sure? Everybody's just looking like, come on, get on with it. Yes, we're going to be doing what time? No, Euclidean is last. Euclidean is last. Euclidean we're going to do after lunch. Euclidean we are going to do after lunch. We got this. I'm going to do that application of functions. We're going to do analytics. That will take us to our first break. Then after that, we're going to go straight into trigs. Right until lunch. And after lunch, we will crack Euclidean, circle geometry. Everybody's lost here. Everyone lost here. Now look. Now look. We got x to the power x is equal to, watch here. We need to make this look exactly like this. So we're going to say, I'm going to say 2 squared into, if I pulled out 2, so 2048 divided by 2. 2048 divided by 2 gives me what? 2 to the power, no, 1024. Yes or no? Yes or no? Remember when we multiply and bases are the same, what are we going to do? We're going to add the power, so that's 1024. Right, we're breaking it up. Watch here, step by step. So so x to the power x is going to equal to, now I keep on taking out a 2 here. Right, so basically here, what do I have? I got 2 to the power. Remember, when we multiply and bases are the same. Oh, sorry. Sorry. If I multiply and bases are the same here, we're not adding the powers. Let's go back. Let's go back. So 2048, I'm opening it up here. 2 times 1024. Yes or no? Right. So that will give me 2 times. Now what is 2 squared? 2 squared is 4. Am I right? So let's put a 4 there. To the power 1024. Right. Now, let's break this one up again. Let's take out another 2. So x to the x is equal to 4 squared into, now, 1024 divided by 2. Because I want to simplify that power to its simplest power. I don't want to work. So what I'm doing is I'm just making the power smaller and smaller. I'm diminishing the power. So 1024 divided by 2, 1024 divided by 2 will give me 512. Yes or no? Right. Now what is 4 squared? So x to the x will equal to 4 squared is 16 to the power. Remember, I need the base and power to be identical. At this point in time, base and power is not identical. Remember, x to the x. It's the same x here. It's the same x here. I'm trying to get the base and the power to be identical. So 4 squared is 16 to the power 512. I'm still not done because the base and power is not the same. So x to the x is equal to, let's go, 16 squared into. Now 512 divided by 2 is what? 256. Yes or no? So what am I left with? X to the x is equal to, what is 16 squared? Now there we go. Something's happening here. 256 to the power 256. There's it. Base power, base power. X and x identical. X and x identical. So what is x equal to? 256. That's how we diminish the power. That's how we make the power smaller and smaller and smaller and smaller till we get the base and the power to be identical. Because it's x and x. The same x in the base, the same x in the power. So I want identical base and I want identical power. With me? It is a higher order question. It is a higher order question. Some of you, if you work through past papers already, you would have come across this. Remember the website where you download? Do you guys all know the website to download all your past papers? Test papers. Just go to test papers. We'll give you all the different provinces. Go and Google test papers. It will give you June exams. If you go on to NSC, past papers, you'll only get final exams national. But if you go to test papers, it will give you different provinces. It will give you their March exam, their June exam, September assessment, as well as finals. And believe you me, a lot of the educators are going to take out questions from there to set your exams or your tests. So that's your resource. That is your toolkit. That's your toolbox. There we go. Yes, it was a bit challenging, McDonald's. McDonald's child. Quarter pounder. That was difficult. It wasn't difficult. It was challenging. It was a bit of a challenge for you grade 11s. All right. We're done with that. Let's see how the question, I took some screenshots of this. Let's see what they give you. The function g. Let's do. This is from your exam paper. Right? I told you we're going to do application of what we did. They told you g of x is equal to a half to the power x minus 4. Now, what type of a graph is this? This is an exponential and it shifted 4 units down. Yes or no? Right. Question number 1. Question number 1, they want the equation of the asymptote. So take this down, the equation of the asymptote. You can start with this already. You don't need to wait for me. As I'm writing the question, you can start working it out. The y-intercept. Calculate the y-intercept of graph G. Question number 3, the x-intercept of graph G. Number 4, sketch the graph. Number 5, the average gradient between x equals 0 and y equals 0. The average gradient between x equals 0 and y equals 0. Right. Write down the equation of k. They want the equation of k. If k of x is equal to g of x plus 4. And that's your first set of questions here, guys. That's your first set of questions. We're then going to be doing a hyperbola with a shift in asymptotes after that. I'll just show you what the parabola and straight line want. You're getting all this in your exam. It's all coming out in your June. Now we know that this graph is given by, what's your standard formula? a to the power x plus q. Yes or no? We did yesterday, if this is a fraction, what type of a graph is it? Positive or negative? Let's see if you remember. Remember, if it was 2 to the x, would go that way. If it was a fraction, it would go that way. So what is this? Is this a positive graph or a negative graph? Negative graph. Very good. It's a negative graph, and we said yesterday, what is a negative graph known as? An increasing function or decreasing? Decreasing. Very good. Right, let's start with this. Onliners, let's see how we're doing. Question, answer. Right, let's go, let's go, let's go, let's go. Right, the equation of the asymptote. The asymptote, so the answer to question number 1 is y equals minus 4. Don't go and say q. Yes, we know it's our q value. But the equation of a straight line is y equals something if it's horizontal, or x equals something if it's vertical. Are you all following grade 11s? We good? The y-intercept. So we got y equals a half to the power x minus 4. What is your y-intercept? Let x equal to 0. Yes or no? Grade 11s, are you all with me? So let x equal to 0. So y equals a half to the power 0 minus 4. Y equals, what's a half to the power 0? 1 minus 4. So y is equal to negative 3. There we go. When x is 0, so the answer to question number 2, when x is 0, y is equal to negative 3. There we go. So we got our asymptote, we got our y-intercept. We now need to get our x-intercept. Onliners, you following? Are we all good? Are you managing? Are you winning? Okay. Let's do number 3. The x-intercept. How do we get the x-intercept, guys? Let y equal to 0. Very good. To get the x-intercept, let y equal to 0. So you're going to have a half to the power x minus 4 is equal to 0. How do we solve for x here? We have to make the bases the same, yes or no? So it's a half to the power x is equal to negative 4 will come on this side as what? 4. So that is a half to the power x is equal to 4 is what? 2 squared. Agreed? Right, now wait. Before we get, now a half is 2 to the power minus 1 to the power x is equal to 2 to the power 2. We need to make the bases the same. So 2 to the power minus 1 times x will be what? Minus x is equal to 2 squared. X, 2 and 2 cancels. Minus x is equal to 2. X is equal to minus 2, negative 2. So there we go. The answer for question number 3, minus 2 and 0. The answer for question number 3 is negative 2 and 0. I'm putting it here on the side because I'm going to need this information to sketch the graph. So we got our x-intercept, we got our y-intercept, we've got our asymptote, we've got all the necessary ingredients to sketch our graph. Agreed? Good. So let's sketch the graph. Guys, this is 10 to 12 marks just here on the screen. Okay. I'm erasing this. This is easy stuff. Let's sketch the graph. Let's sketch the graph. Question number 4. Let's sketch the graph. Here we go. So y-axis, x-axis. Let's go in. Right. Y is equal to negative 4. 1, 2, 3, 4. So that's your dotted line, your asymptote going through negative 4. And if you want to, you can write y equals minus 4 there. And that is your point, 0 and minus 4. 0 and negative 3, 0 and negative 3 is my y-intercept. There we go. Minus 2 and 0. Minus 1, minus 2 and 0 is your x-intercept. We know it's a negative graph, so it's going to go in that direction. So here we go. Here we go. Draw your curve. Draw your curve, making sure that it doesn't touch your asymptote. And don't forget, call it graph G. That's 0 in the middle, and that's your x-axis. And there we go. You got full marks. So we got full marks, full marks, full marks, full marks. Now, average gradient. We all okay, guys? Lovely. Bombo. You keeping up? Let's go. So we're done with that. Average gradient between x equals 0. Between x equals 0 and y equals 0. So when x was 0, y was negative 4. So basically it's between these 2 points. Between x equals 0 and y equals 0 is between these 2 points. Basically, let me just show you the average gradient between these 2 points. Basically, they're telling you that there's a straight line going through them. And we need to find the average gradient between these 2 points. So I'm answering question number 5. So between x, this is y equals 0 and x equals 0. They want the average gradient. So what's your average gradient? Average gradient is equal to, we know, y2 minus y1 over x2 minus x1. Your normal gradient formula. Now we can call this x2, y2. We can call that one x1, y1. We're going to be using this in analytics. So your average gradient is now going to equal to y2 minus y1. 0 minus minus 4 is 0 plus 4 over x2 minus x1 minus 2 minus 0. That will give me 4 over negative 2. Your answer is minus 2. Yeah. Sorry? Why? A minus 3. Oh, sorry. Oh, my word. Thank you for that. Yo. That was 0 and negative 3. Astaghfirullah.
Mr. Khota, better get that money ready.
Astaghfirullah.
Better get that money
Lovely.
ready.
Thanks for picking that up. Yo. Thank you, guys. So y2 minus y1 over x2 minus x1. So this x1 here, thank you for picking that up, is 0 and negative 3. That's that point, 0 and negative 3. Between x equals 0 and y equals 0. Right. So y2 minus y1. 0 minus minus 3, 0 plus 3 over x2 minus x1, x2 minus x1. Your answer is 3 over negative 2, which is equal to minus 3 over 2. There we go. Thank you so much. La hawla wa la quwwata. Yeah, they sharp today. They sharp. Thank you, thank you, thank you. As bruh, if you are correcting me, it means you know your work. If you are correcting my mistakes, then you sharp.
I smell a distinction.
Many. Right. The equation of k, if k of x is equal to g of x plus 4. The equation, so what was g of x? Right, so k of x, let's answer question number 6. K of x is equal to, what was g of x? A half to the power x minus 4 plus 4. Yes or no? G of x was a half to the power x minus 4. And now they say plus 4 at the end. So what is the equation of k of x? Minus 4 plus 4 will give me 0. What do I get? A half to the power x. Very good. So that means this graph shifted 4 units up. Are you all with me, guys? Excellent. Well done, well done, well done. Let's see. Let's give you the next one. Okay. The function. Now I'm going to show you this equation, the hyperbola with a shift in asymptotes, and they tell you has an axis of symmetry with an equation. So, right, let's go through this. Let's see what we do with the next question. Onliners, are we all good? Thank you so much. There we go. Right. Take the next set of questions down. So this one is the exponential. We're done with the exponential. They say f of x is equal to a over x plus p plus 1. Now, don't let this thing confuse you. Although they tell you x plus p, you know that the standard equation has got what? X minus p. Right. Has an axis of symmetry. Has an axis of symmetry. Given by x equals 3 minus y. Right. Question number 1. They want the range of f. Question number 2. The equation of the vertical asymptote. Of f. Number 3, if f of 0 equals 2, find the value of a. The x-intercept of f. Find the x-intercept of f. Sketch the graph. Write down the values of x for which f of x is less than 0. They want the value or values of x for which f of x is less than or equal to 0. Right, let's work on this. Let's work on this. And then I'm going to show you from this very paper, the parabola that they gave is the same as the parabola I gave you yesterday. Only thing with the change of values. Grade 11s, you need to be able to interpret this. You need to be able to convert it to English language. Now we know, is this in standard form? No. We know that the axis of symmetry is y equals mx plus c. Am I right? So let's first put this in the form y equals mx plus c. Let's put that in the form y equals mx plus c. So x minus 3 is equal to minus y. Minus y equals, I'm just swapping the two around, x minus 3. So y equals divide by negative, divide by negative, divide by negative. So minus x plus 3. So therefore, this is the axis of symmetry with a negative gradient. Yes or no? Right. What is the range? Now, just to give you, we know that that is my y asymptote. So to answer question number 1, I don't have a memo here. I'm just doing it as if we are all answering it in the, all I did was I took a screenshot of the question. That's generally what I always do. I never take a screenshot of the memo because we put ourselves under pressure. Because I want to show you that this is how we need to analyze, this is how we need to look at a question. So now, let's answer question number 1. What do we know? We know that in any graph, they're asking you for the range of this graph. So now they're telling us, so we know that the y asymptote is going to be at 1. That's my Q value. So we know that my y asymptote is going to be at 1. So what is the range of f? Y, we don't know what A is yet. So whether the graph is here and there, or whether the graph is there and there, makes no difference. My range of f would be y is an element of real numbers, or negative infinity to positive infinity, but y can't equal to 1, because 1 is my asymptote. Yes or no? So to answer this first question here, now all I'm doing, let's just rewrite this one here on the top, this equation of the axis of symmetry. I want to put it here on the top. Let's rewrite it. Y equals minus x plus 3. Let's answer the first question. Let's answer the first question. So the range of f would be any value less than 1, any y value greater than 1. So we can say y is an element of real numbers, but y cannot equal to 1. Or you can say negative infinity to positive infinity, but y cannot equal to 1. You can put that one or this one. You don't need to put both. You don't need to give both in your exam. You can just give one. Good, 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 good. Right. The equation of the vertical asymptote. The equation, now this line, remember, interesting, the equation of the vertical asymptote. Now, no values are given on our graph. No values are given on our graph. It's interesting. I've never seen a scenario like this asked. Normally, they'll ask, you know what the questions will be? Find the x-intercept, give the equation of the asymptotes, right? Then they'll ask you find the x-intercept, find the y-intercept. Then afterwards, they'll ask you find the equation of the axis of symmetry. Now they are asking you they gave you the axis of symmetry from the beginning. Now, what do we know from yesterday's lesson? The axis of symmetry goes through our two asymptotes, am I right? Doesn't the axis of symmetry go through where the two asymptotes meet? Right. So now I'm talking to yesterday's lesson. Right? I haven't done this question before. I've never done this question before. I'm doing it with you. I'm analyzing it for you as if I am writing this paper with you in the exam. So I just drew a rough sketch of what we knew. It's always good to draw a rough sketch so you have a picture of what you know. Now let's see. Don't write. I might be right, I might be wrong. I don't think I'll be wrong, but let's see. The equation of the vertical asymptote. Now we know we got y equals minus x plus 3, my axis of symmetry. And I know that my axis of symmetry is my P and Q value. We know my Q value here is 1. Yes or no? So I can put, so basically y is my Q value is equal to, right, so let's go. Instead of y, what can I put? 1 is equal to minus x, which is my P value, my vertical asymptote, this here. That's going to be my vertical asymptote, plus 3. So 1 minus 3 equals minus x. Minus 2 equals minus x. The algebra takes over. X is equal to 2. Yay! That's my P value. That's my vertical asymptote. Now you can take that down. I don't think I'm right. We know we're right. There we go. X equal to. Taken from where? Where did we get it from? We got it from our axis of symmetry. Because you know your axis of symmetry cuts, goes through where your two asymptotes meet. The same x and the same y for your axis of symmetry is the point where your two asymptotes meet. We did that yesterday. We did that yesterday. So for those of you who just joined us today and you missed yesterday's session, remember these sessions are recorded. You can go to the Awqaf website or on YouTube, Awqaf SA, and go and re-watch yesterday's episode. The whole session. We did a lot of work yesterday. Right, onliners? Are we okay? Are we winning, guys? Are we winning? Mr. Martin, 2024, are we good? Zane, Lombard, we good? Onliners are quite quiet now. Okay, so there we go. There we go. X is equal to 2. And like I told you, see what I did. How did I attack this question? I first drew a rough sketch on the side. I drew a rough sketch of the information that was already given to me. You're not going to be able to get your answers direct. It will be. Excuse me. It will just be a little bit more challenging if you're answering it from your questions. Draw a rough sketch. Draw a rough sketch. So we're done with that. We're done with that. We're done with the vertical asymptote. We're done with the range. First time I've seen a question like this, but wow. I'm glad we did it. I'm glad we did it. Okay, interesting. If f of 0 equals 2, so f of x is equal to a over x. We got the vertical asymptote here, guys. What's my vertical asymptote? 2, right? Sorry, that's not, that I circled, that's not 0. So let me just erase that so it doesn't confuse you. That point is 2. 0 is here. That's 0. That's your axis. That's your y-axis. This is your x-axis. Right, it goes through 2, that point there. Right, so it's a over x minus 2 plus 1. Here we go. If f of 0 equals 2, what does that mean? For every x, I need to put, this is strange. Let me double check. I hope it's not minus 2. Let me double check. If f of 0, oh, if f of 0, that means for every x, I need to put 0. That's what it means. So watch here. A over x is 0 minus 2 plus 1. This is f of 0 equals 2. It doesn't mean that for every x I need to put 2. F of 0. That means for every x I must put 0. So now that's a normal equation. Let's solve for a. Come on, we are in grade 11 now. A over 0 minus 2 is minus 2 equals 2 plus 1 will come on the other side as minus 1. A over minus 2 will equal to 2 minus 1 is 1. I want a on its own. We multiply this side by minus 2 over 1. We multiply that side by minus 2 over 1. So therefore, a is equal to 1 times minus 2 is minus 2. There we go. That's your value of a, and you will get 4 marks for that. Okay? We all good, guys? Now they want, right, now you do number 4 and 5. Give me the x-intercept. Give me the x-intercept and then sketch the graph fully. Finish it up. This is the last. We're almost at the end of the functions component. Let me look at that parabola so long. There we go. All right. Let's see. And that shortcut's going to come into play. You'll see whatever I showed you yesterday is going to come into play. Onliners, how are we doing there? Time for break is 10:30. You're winning and you're learning. Well done, well done. Well done. Give me the x-intercept and sketch the graph. Give me the x-intercept and sketch the graph. So now we got a equals -2. So now basically we actually got the entire equation. A is equal to -2. A is equal to -2. Let's go there. Let's change that. Please go back to your equation and change. There we go. Now, how do we get the x-intercept, guys? Let y equal to 0. So -2. I'm answering question number 4. I'm answering question number 4. Let y equal to 0. So you got -2 over x minus 2 plus 1 equals 0. Let's solve for x. We are now finding the x-intercept. So let y equal to 0. And we need to sketch the graph here thereafter. So let's go. -2 over x minus 2 equals -1 over 1. You can cross multiply. -1 into x minus 2. -1 into x minus 2 is equal to 1 times -2 is -2. Minus x plus 2 equals -2. Minus x equals -2 minus 2 minus 4. X is equal to 4. So x is equal to 4. That's 0, 1, 2, 3, 4. And what was the y-intercept? Did we work out the y-intercept? They asked you for the x-intercept. They asked you for the a value. Is there... So now we know this is negative graph. So the one graph is going to go like this, in this direction. That's your x-axis. That's your x-axis. That's your y-axis. Right. Let x equal to 0. Let's get our y-intercept. They asked you to sketch the graph. They asked you to sketch the graph. So we now got f of x is equal to that. Now we're going to say let x equal to 0 to find my y-intercept. So y equals -2 over 0 minus 2 plus 1. Y equals -2 over -2 plus 1. Y equals 1 plus 1. Y is equal to 2. So when x is 0, y is 2. Let's go here. When x is 0, y is 2. You have to show that point. 0 and 2. Now let's sketch the graph. Now let's sketch the graph. I just want to erase that. It's a negative graph, so in which two quadrants will it appear, guys? Your second and your fourth. Very good. It's a negative graph. So that means your first graph goes like this. Remember, these two are your asymptotes. There's your one asymptote. There's your other asymptote. Now your one graph will go like that. Because it's negative, it's in your second and in your fourth. And the other graph will go like that. Beautiful. Wow, we just scored full marks for that, guys. We just totaled that in the exam. We just scored full marks for that. Onliners, I hope you guys all got that. I hope you guys all got that. Onliners, I hope you did some self-assessing here as we went along. Now the last question, the values of x for which f of x is less than or equal to 0. Where is f of x less than or equal to 0? Let's answer this question, number 6. Where is f of x less than or equal to 0 means below your x-axis. Remember, we did this yesterday. That's your question. In your answer, where is this graph negative? Where is it below your x-axis? So it's below there for all these values of x. Now there's an equal to sign. So x less than or equal to 4. It's for all these x values here. But you can't say equal to 2 because 2 is your asymptote. So you just say x less than 4 but greater than 2. You can't put an equal to sign next to 2. Why? 2 is our asymptote. Agreed, guys? Onliners, we okay? And that brings us to the end of that. That brings us to the end of that. Let's now do quickly, just to show you that parabola. We'll then go into, we'll start with analytics. We're going to start with analytics or Attile. We're going to do this and then we're going straight into paper 2. Right. We're then going to do analytics, the angle. I'm sure you all did the angle of inclination. You all did the angle of inclination? Right. Excellent. Excellent. Let's start. Okay. So they give you a graph like this. You can take this one down with me. They give you a graph straight out of a past paper. And nice. What did I tell you? I told you I got a feeling, I got a hunch that they're going to give you a negative parabola. They give you this as -3 and 0. They give you this as 1 and 0. They don't give you, they call this point M. And they give you this y-intercept as 6. H of x is equal to ax squared. So we have to find a plus bx plus c. Question number 1. They want the coordinates of D. Okay, then they gave you another. Okay, so let's just say, no, let's do this. They gave you another graph, but I'm not going to do this. They now say, show that A equals -2, B equals -4, C equals 6. Then question number 2, find the coordinates of M. They want the coordinates of M, the turning point of graph H. Then they want the range of H. And where is H of x less than 0? Right, let's do this together, guys. This is the last component of your functions. This is the final component of that functions application. I just did this as additional work to fully prep you, because yesterday we did all the processes. Now I'm showing you how that processes that I showed you yesterday is applied to your past paper. This is how you get 100% in math. Okay, let's go. Let's go, let's go, let's go. Right now, where is A, where is B, where is C? If the answer is not on your graph, it must be in your equation. If it's not in your equation, it must be on your graph. So A, B, and C. A, B, and C. Basically, what do they want? The equation of the function. Yes or no? So let's answer question number 1. Isn't this what we did yesterday? What tool do we use when two x-intercepts are given? Don't we use y equal a into x minus x1 into x minus x2? Yes or no? Didn't we do this yesterday? So now we can call this one x1, let's call that x1, let's call that x2, and this is 0 and 6. Any point on the graph, and that's x and y. So what's y? 6 equals a into, what's x? 0. Minus 3, plus 3, into x is 0, minus 1. 6 is equal to a into 0 plus 3 is 3, 0 minus 1 is minus 1. 6 equals minus 3a. A equals 6 over minus 3. A equals negative 2. Boom. There we go. A is equal to negative 2. What did I tell you yesterday after we found A? Was that our final answer? What must we do with that A? Sub it back into the original equation, correct? This is exactly what we did yesterday. Now take this A and put it. Come, you guys continue with it. Sub it back, expand it, and get it into a quadratic form. Get it into ax squared plus bx plus c. Those of you who were here yesterday, you'll know exactly what we did. We're now going to take the negative 2 and we're going to put it back into here. So y equals minus 2 into x minus 3 is plus 3 into x minus 1. Now you'll notice that if you use the right tool and you follow the correct algebra, the problem is going to work itself out to the answer. The problem will work itself out. The mechanics will work itself out. You press the right buttons, you're going to get the right result. I know we're going to get B is equal to minus 4. I know we're going to get C equals 6. Why do I know that? Why am I so confident? Because we've used the right tool. So now y equals minus 2 into, now if we FOIL this out, this will be x squared, plus 3 minus 1 will be plus 2x minus 3. Here we go, the moment of truth. The moment of truth. Let's multiply this out. Minus 2x squared minus 4x plus 6. B is equal to minus 4. A, B, C. There we go. And we don't even, to check whether we're right, we know our y-intercept is 6. We know our y-intercept is 6. We know we're right. That's another point if we can check of how correct we are. Agreed? Thumbs up. You all understanding? We good? Lovely. Right, now you can do the next one. Coordinates of M, the turning point. I showed you guys, I gave you a new formula yesterday. I gave you a formula for X and I gave you a formula for Y. I gave you a formula for X and I gave you a formula for Y. So minus 2x squared minus 4x plus 6. Let's go back. Go back and change your equation. H of x is equal to minus 2x squared minus 4x plus 6. We're done with this. The coordinates of M, the turning point. We're answering question number 2. So the turning point, the coordinates of M, minus B over 2A. And for those of you who were here yesterday, I showed you a new formula. What was it? Do you remember? 4AC minus B squared over 4A. Yes or no? So minus B minus 4 over 2A. 4AC minus B squared over 4A. There we go. This would be 4 over minus 4, which is negative 1. 4 times 2 is 8. 8 times 6 is 48. Minus 48 minus 16 is minus 64 over minus 8. And it's 8. You can do it mentally if you want. Let's double check. 4 times minus 2 times 6 minus 48 minus 4 squared is 16. Minus 64 divided by minus 8. Boom, we are right. So M's coordinates is minus 1 and 8. Now go back there to your diagram and put minus 1 and 8. Go to your diagram and put negative 1 and 8. Does this graph have a maximum turning point or a minimum turning point? Does it have a maximum y value or a minimum y value? Maximum. A negative graph has got a maximum. So that's your range. That's your range. That's your range. Well done, guys. Well done, onliners. You're all coming right. Good to see. The range of H. So answering question number 3, it's all your y values less than or equal to 8. Why? Because it's got a maximum y value of 8. So it's all your y values less than to negative infinity, because your arrows go down to negative infinity. Y less than or equal to 8. And the last question. And the last question to wrap up our functions. Please, guys, now that you're getting the hang of it, you're excited. Now you probably, some of you are seeing functions for the first time clearly. Now you go home and you practice on the processes I taught you yesterday, or we all did together. You practice on the processes you were taught at school. You practice on the ones that we've done today. And now you start applying it to past papers. That's how you study math. After knowing the laws, after knowing the processes, now you attack a whole stack of past papers and you work in a group. 2 or 3 of you work together. But please make sure that even the group members that you choose are quite of, you can't get 3 domcops working together. You'll all fail beautifully, right? So please make sure some people in the group know what's going on, right? Otherwise, you'll all fail. You'll have the blind leading the blind. So please choose the people who you study with, your study groups. Don't just choose your best friends. Okay. The range of H. So we've done with that. Let's do the last one. Where is H of X less than 0? Where is H of X less than 0? That means where is your graph below your x-axis for which values of x? So it's below here. All these x values will give you values below. And for all these values here, it will give you a value below. Because this goes on to infinity, remember. So it's for all, there's no equal to sign. There's no equal to sign. So you say for x to the right of 1, or all your x values to the left of negative 3. There's your answer. That brings us to the end of functions and its application. So we did some higher order algebra to warm you up this morning. And we did some functions, a little bit of each of the graphs. Okay, let's go into analytics. We're now going to do 10 minutes into analytics until break. We'll come back, we'll finish up the analytics, and we go straight into trigonometry. Right. And I'm going straight into past papers. This is June. I'm not going to be explaining trigonometry from scratch. We're going to go straight. We're going to take past paper models. We're going to be applying it. By now, you should know your tools. But as we go along, I'll emphasize on the tools that need to be used. I'll work through the memo with you step by step, item for item, like we always do. All right, I won't leave you to swim with the sharks by yourself. Right, onliners, we ready, guys? Let's go. Yes, Nomvi, because you lost today because yesterday you did not do the function. So obviously you're going to have to go back to our recording on yesterday. For those of you who just joined today, you've missed out a hell of a lot on all the type of processes that we did yesterday in functions. Right? Obviously, because time is against us, I cannot go and redo yesterday's work. Okay, let's start into paper 2. We're going now into paper 2. Let's start with analytics. Let's take a model down quickly. Let's take an exam model.
Mr. Khota,
Yeah,
I have
yes.
posted the YouTube session in the chat now. So for that lady that's lost, she can be found. She
Oh,
can find
lovely,
herself.
lovely, lovely, lovely. There's it. There we go. There you go. On YouTube, you can go onto, there's the link. The host Hasanain just posted the link. You can also go to Awqaf SA. You can search it on YouTube. You can even go to Awqaf SA, the website. And all the sessions are on there. Okay, let's take this one down, guys. Let's make up a model. Let's make up a model. All right, so I'm going to give you one that goes like this. Come, take it down with me. That's your y-axis. Let's go from here to here. It doesn't go through 0. And let's go from there to there. All right, this is June exam prep. So let's go here. Right, let's call, obviously that's your y-axis. This is your x-axis. Let's give it any value. Let's call it P, Q, R. Let's say point P is 4 and 30. Let's say point Q is -8 and -10. Let's say point R, let's come up with another value here. Let's say R is 12 and 6. I'm intentionally using different values so that you know when we're substituting into formulas which value went where. I'm not using the same values. So when you're practicing on this, you'll know exactly what to do. Right. I tell you that this is angle alpha. I tell you that this is angle beta. And I tell you that angle Q is angle theta. Question number 1. I want the gradient of QR. Question number 2. I want the equation of QR. Question number 3. Find angle alpha. Find angle theta. Right. If S, X, and Y lies in the fourth quadrant, such that PQRS is a parallelogram, a palm, find the coordinates of S. Right, let's give you mark allocations here, guys. The gradient of QR, 3 marks. The equation of QR, 4 marks. Find angle theta, 3 marks. Find angle alpha, 3 marks. Find angle theta, 5 marks. If S, X, and Y lies in the fourth quadrant, another 3 and 3, 6 marks. Let's see how many marks in total here. 6 and 5 is 11 and 3 is 14. 14 and 4 is 18. Let's make it an easy rounded off number. Let's give you the first one only for 2 marks. Come on, because that's easy. Here's a 20-mark set of questions. An opening set of questions for analytics. Okay. We got 6 minutes. We're going to kickstart this analytics until break. Then you're going to go for your comfort break, your breakfast break. And then you're going to return at 11 o'clock. You got a 30-minute break. We come back and we push until lunch. Lunch will be at 1:45. Then we'll push through. You'll have lunch until 1:30. And then 1:30 to 3 p.m. we finish up. Okay, that's the program for today. We will complete everything. We'll complete analytics, we'll complete trigonometry, and we will complete the entire Euclidean for 2025. All right. Okay. The gradient of QR, come on. Now the M of QR, you have to put the formula in. You get a mark for the formula Y2 minus Y1 over X2 minus X1. So QR, they want QR. You can call anyone X1, Y1. Let's call this X2, Y2. I'm just going to call it for X1, Y1. Right, Y2 minus Y1 over X2 minus X1 minus 8 plus 8. 6 plus 10 is 16 over 20. 16 over 20 gives you how much? 4 over 5. There we go. Your first 2 marks. It's easy. You have to score full marks here. You have to score full marks here. Two minutes left. Find me the equation of QR. Now listen to me. The minute we're done with this, the M of QR is 4 over 5. QR, M equals 4 over 5. Now let's find the equation of this line of QR. Now you got a point and you got a gradient. So let's do this. I'm erasing this. Now I don't know if you've seen this formula, but I'm going to use this formula when you have the gradient and you have any point. Then we're going to use y minus y1 equals m into x minus x1. Have you seen that? Yes? Good. Use this formula. And then we just remove the brackets and bring it in the form y is equal to mx plus c. Correct. So do it. Start it. And this is going to take us until break. We're only going to do these first 2 questions. After break, we're going to do question 3, 4, 5. After break, we're going to do question number 3, 4, and 5. Substitute, it's 4 marks. I told you yesterday, mark allocation divided by 2 is your time. So we got exactly 2 minutes. So let's all use the same point, 12 and 6. You could have used point Q also. You can choose any point from the line. So y minus 6 is equal to 4 over 5 into x minus 12. Y minus 6 is equal to, multiply this out, 4x over 5 or 4 over 5x minus 12 times 4 is 48 over 5. Now take the 6 on the other side. Here's your final answer coming up. Y equals 4 over 5x minus 48 over 5 plus 6. Minus 48 over 5 plus 6. This gives us our final answer of minus 18 over 5. And that takes us to break. On point. Yeah. Now we got 3 seconds, 5 seconds in 5, 4, 3, 2, 1. And 10:30 on the dot.
Well done, Mr. Khota.
Here we worked to the last second here, bro. How that thing worked out?
It's good, it's good.
Wonderful. Is beautiful. Enjoy your break. Enjoy your coffee. Enjoy your McD's or whatever you are going to be having for breakfast.
South Africa, a country where necessities are a challenge and reality in poor communities. Awqaf SA is on a drive to make a positive change in people's lives. Our work is deeply rooted in the ethos, history, and belief of our religion. Through your Waqf donations, we are building a brighter future for education, healthcare, and infrastructure, and fulfill a sunnah in paving a way towards a brighter tomorrow. With your support, Awqaf SA has the power to transform lives for generations to come. Donate today and build a foundation for a brighter tomorrow. Awqaf SA, creating an eternal legacy of hope and dignity.
Are we good, brother? Can I talk?
The guys also standing in front of the camera.
Okay.
So I'm just waiting for them to basically go out.
Okay.
And then I can just swap over because if you
But I need to do it now.
Can I do it now?
Yeah. Okay, here we go. Okay, sorry. Sorry. Okay, we are here. Okay, South Africa, we are here at South Peninsula High School. First, we will be calling on the HOD, Melissa Meyer. Please come and speak to us. Tell us how is the session going. And I see you've been frantically marking and catching up with some of your admin work over here. Come join us. That's the camera over there. So tell us, how's the session been going from a HOD point of view?
First of all, I would just like to say thank you so much to Mr. Khota for all his jokes and fun things that he says to the learners to help them remember the concepts. And I'm sure that many of them are going to walk away with having, learned quite a few tricks and things that can help them. It will stick in their head because of just the way he explains. Yes, I have been catching up with some of my marking in the back, but I definitely have been listening as well because it is so interesting. He's really exciting, the energy that he gives. Yes, thank you once again. We are very privileged and lucky to have you here at SP.
So Melissa, I take it that you're going to be implementing some of Mr. Khota's quirks and his high level etiquette in conducting the thing. What you say to that?
As I spoke to Mr. Khota yesterday, I have been taking some notes of some of his jokes, but I'm not sure if I can pull any of them off. I will try. I know there are some really cute methods, like the snotkop method, that even my learners have told me about. So, yes, I will try, but I don't know if I can do it like Mr. Khota.
Yeah, so there we go. So here at the Awqaf is a maths workshop coming to you live from South Peninsula High School. You know, everyone is all smiles. We're high energy here because of Mr. Khota, the educators, and everyone that's here. We're going to draw attention to you. You must let us know. You know, you've been sitting in the front row here. I think we need to give a special award of merit to you. Tell us, how's the session been going and how is it assisting you for your June exam prep?
Bit nervous. My name is Philkees Charding. I'm in grade 11, and this session has made me feel excited and willing to learn more. The methods that Sir gave us, it is very exciting, like the Snotkop method, and I think for the June exam, it's preparing me to think more and understand what's gonna come with the exam and stuff.
Yeah, so I'm looking at all of your smiles, you know. There's like a high energy that's in the room. Is that benefiting your preparation?
Yes, this is a lot. It's helping me excited. I love maths.
Oh, lovely. And we speak to you, sir. Tell us your name. Tell us what's the vibe like here in the classroom. You were part of the maths paper one or maths paper two today. Tell us how is this motivating you more and sharpening your proverbial sword in preparation for the exams?
So my name is Luke Murphy, and being in the workshop for the 2 days, it has really opened my mind, and I got to learn few shortcuts from Mr. Kota, and it also helps me prepare better for the upcoming exams, and I think that, or rather, I know that I will do great.
Yeah, so we're gonna bring Mr. Cote in here into the picture here. It's very heartwarming to get some of this encouragement. And do you know what's the opportunity for us? Is that you're in grade 11. In grade 12, you're gonna be with us. You're gonna be with us for August and October. So my word, you know, we're onto such a positive change. Mr. Cote, just give us some reflections here. The energy, the here's the vibe, online, offline, SP.
I think Melissa, I think Ma'am Mayers is a bit too kind. But yeah, it's been an absolutely amazing experience being here in Cape Town and being with this cohort of learners, the high energy, the smiles, the way they're engaging with the program, and the way their work ethic. And I'm sure even our onliners, I mean, that has been also such a tremendous, because we get to see on the back end of things as we sit there on the PC, and we see all the comments, the positive feedback that's coming from the learners and the amount of learners that are engaging from all over South Africa. So I just want to thank Awqaf South Africa as well as SP and all the learners, as well as these learners. You guys too kind. But yeah, I mean, it's all your effort. It's all your hard work. And obviously, thank you for taking out your time, especially ma'am and the learners who have taken out their time on a weekend, which is like a weekend just before examination, to spend an entire boot camp with us and all the thousands of learners that have joined us online. So from my side, it's just been an amazing experience as usual. And I can tell all the learners, follow your passion, and that's all we're doing here, following our passion, and our passion is numbers, our passion is mathematics, and I hope that we can transfer some of that energy and that some of that passion onto you as a learner, onto you as a viewer, where you saw math as being a dull subject, as you've seen math being something dreary, something nightmarish. Now you've got a whole new vigor, a whole new excitement to tackle math. Even some of the problems that we did some higher order stuff, right? Challenged you, rocked your boat. But that's what math is all about. We can't get that level ones all the time. It's not going to give you that challenge. So we want that spice.
So there we go. So this was also a reality check for some of the learners. There were challenged yesterday in Maths Paper 1. Some of the questions that Mr. Khota was posing. And also that we want our grade 11 learners to score maximum in the June exam. All right. And it's not only about grade 11, it's about making that transition, like Mr. Khota said, from grade 10 to 11. It's a quantum leap, but also it's a very sound foundation for your future. It's not only grade 11, it's grade 12. Anything from your side in terms of some of the teaching methods? And we were also talking yesterday during the intermission that, we would like to, and also get SP's, South Peninsula's input around an educator training workshop. Just in conclusion, just tell us just some of the take homes that you take from the session in terms of how they can be implemented in a maths classroom scenario.
Okay, so from my side, just coming up with little ways that they can remember, that really helps, and also showing the patterns and the trends, because I think they haven't gone through enough papers in order to see those patterns. So reminding them, okay, this is what you'll see when you see that, and this is what you do here, and all of those patterns. It does help, especially going through numerous question papers, as we can see you have. Yeah, just best practices. What's the best way to go about going through a question? You also told them, don't do something this way because you'll take too long. Do it this way. That really helps them. They will take home, better ways to go about some of those questions. And just one more thing from my side. Again, the onliners and everyone who was here. It's a Sunday. Well done to you. Yes. Well done.
And ma'am, for taking out your time for being here.
So there we go. We're coming to you live in true effect from South Peninsula High School here in Plumstead, Cape Town. We will resume at 11 o'clock. Thank you so much.
South Africa, a country where necessities are a challenge and reality in poor communities. Awqaf SA is on a drive to make a positive change in people's lives. Our work is deeply rooted in the ethos, history, and belief of our religion. Through your Waqf donations, we are building a brighter future for education, healthcare, and infrastructure, and fulfill a sunnah in paving a way towards a brighter tomorrow. With your support, Awqaf SA has the power to transform lives for generations to come. Donate today and build a foundation for a brighter tomorrow. Awqaf SA, creating an eternal legacy of hope and dignity.
QR. So tan alpha, we worked out the M of QR was 4/5. So angle alpha is equal to, we go to our calculator, we press shift. So shift tan 4/5, we get 38.65. Let's make it 38.7 degrees. 38, yes. What, of my mic? 30, yes. 38.7 degrees. 38.7 degrees. There we go. There we go. There we go. So here we go. Tan of angle alpha is equal to the gradient of the line. So we got this as 38.7. Now that was the easy one, guys, for 3 marks. The next one is worth 5 marks. Onliners, the next one is worth 5 marks. This is the topic you can score full marks in. When we're done with this, we're going into trigonometry. It's going to be lots of fun. There are different acronyms. Remember, I'm sharing with you all my notes that I use to master mathematics. So even with our identities, I'll show you different methodologies, right? Nice mental acronyms that we use. Okay, let's go. So we're done with that, 38.7. Now, we now need to find angle theta. We now need to find angle theta. Angle theta is there. Now be careful. Angle theta doesn't lie on your x-axis. So now, we know that this angle here is 38.7. We know that this angle and this angle here is vertically opposite. I'm going to put an arrow there. That angle there is also 38.7. So basically, I need to find angle beta, and then I'll find this angle here. Pay attention. We can call that beta 1. We can call this angle beta 2. Because this in itself is a triangle. Then we can use sum of angles of a triangle to find angle theta. So that is angle alpha. That is angle alpha, 38.7. This angle here, beta 1, beta 2. Let's calculate beta 1. Tan of angle beta 1 is equal to the M of PQ. It touches PQ. Pay attention, guys. Tan beta 1 is equal to y2 minus y1. We're using PQ. y2 minus y1 over x2 minus x1. So tan beta 1 is equal to 30 plus 10 is 40 over 4 plus 8 is 12. Beta 1 will equal to shift tan. Let's go to our calculators, guys. Shift tan fraction 40 over 12, 73,3. So this angle here on the top is 73,3. So beta 2 will equal to, this is angles on a straight line. Therefore, angle beta 2 is equal to 180 minus 73,3, which gives me 106,7. 106,7 degrees. This beta 2 is 106,7. Why? I'm just going to put the reason here on the side. Adjacent supplementary angles on a straight line add up to 180 degrees. Now we have a triangle here. We got beta 2. There's a triangle. There's a triangle. So we want angle theta. Theta is equal to 180 minus 106,7 plus 38,7. Why? Sum of angles of a triangle add up to 180. So angle theta is equal to, here's your answer coming up, guys. 180 minus 106,7 minus 38,7. Boom. 34,6 degrees. 34,6. And there we go. We got ourselves another 5 marks. Identify a triangle. Identify. And here we're using the angle of inclination. We are using the angle of inclination in order to find angle theta. Onliners, are we good? Sound clear, picture clear, content clear, understanding clear? Learn this. You got to know this. It's coming out in your exam. 100% in grade 11 in every maths paper 2 under analytics. You're definitely going to see angle of inclination in every analytics. And analytics is a section you want to score full marks in. Right. Let's do the last one. If S, X, and Y lies in the 4th quadrant, so quadrant 1, 2, 3, 4, such that, let's do it in a different color, such that PQRS, there's S. Here's, no, they say in the 4th quadrant. Okay, so let's do that, and let's do that. S, X, and Y, such that PQRS is a parallelogram. So now that means this is parallel to that, and that is parallel to that. Find the coordinates of S. Now, whenever they give you a parallelogram, and you need to find the coordinates, both are, you need to find a pair of coordinates, like one of the vertices of the parallelogram. Go for the best method to use is go with your midpoint formula. Which formula do we go with? Midpoint. Go with your midpoint. Go with your midpoint. So let's go with the midpoint to find S, X, and Y. Okay, let's go. Let's do it. Right. Why do we go with our midpoint? Because we know that the diagonals bisect each other. So the same midpoint for the one line is the same midpoint for the other line. So whenever, if you want to write this down, you can take it down. Whenever you need to find the vertices or the vertice of a parallelogram. Now it can be any parallelogram. Can be a rhombus, can be a square, can be a rectangle, can be a tilted prism. We always use the midpoint formula. Why? Because the diagonals bisect. Remember, that will equal to that, and this here will equal to that there. So let's find the midpoint using QR. So the midpoint of QR is going to be x1 plus x2 over 2. Please know your formulas. y1 plus y2 over 2. So we're using QR. QR, x1 plus x2 over 2, y1 plus y2 over 2. That means your midpoint, 12 minus 8 is 4 over 2 is 2. 6 minus 10 is minus 4 over 2 is minus 2. So that point there, okay, it's not drawn to scale, but it's 2 and negative 2. Your midpoint is 2 and negative 2. I know it doesn't look like it on the diagram, but the diagram is not drawn to scale. Now we go ahead and we find S. That's what we need to find. Now we go ahead and find S. Now go for it, guys. How are you going to find S using your midpoint formula? How are you going to use your midpoint formula to find the coordinates of S? So this is what we do. To find S, to find the coordinates of S, we know x midpoint is equal to x1. Now change the formula slightly. Plus x2 over 2. Y midpoint is equal, you know, to find the y coordinates of your midpoint, you're going to say y1 plus y2 over 2. Make it an equation. So when you're finding a vertex, use this formula. Use that formula. Now let's do it together, guys. Put your pens down. What's x midpoint? 2. Equals x1, which is x, plus x2, which is 4, over 2. Y midpoint is how much, guys? Negative 2. Is equal to y1, which is y, plus y2, plus 30, over 2. All we do now is we solve for x and y. And you do it just like this in a pair of coordinates. These are templates. You go home and you practice on these templates. You make sure you memorize them. You make sure you can do them. So let's solve for x and let's solve for y. Times 2 times 2, we left with 4 equals x plus 4. X equals 4 minus 4 is 0. Times 2 on this side, times 2 on that side, minus 2 is equal to y plus 30. Y equals negative 34. So your x is 0 and negative 34. 0 and negative 34. There's actually this line here, this point here actually lies on your axis. Like I said, just not drawn to scale. And there we go, guys. We are done. There we go. We are done. Let's go into trigs. That is your analytics. In your final exam this year, you're going to get two. Listen, you're going to get two analytics questions. One for 18 marks and one for 12 marks. Total marks at the end of the year, 30 marks. 30 marks. Plus 20 for data handling, that makes 50. Plus 50 for trigonometry, that makes 100. Plus 50 for Euclidean, that makes your 150 at the end of the year. All right? Same setup. Remember, you are matriculants now. You are grade 12s. You are not grade 11s. The same work you're doing now is the same work you have to remember for next year. Everything in grade 12 is based on this work. Let's go. Right. Time for action. Put the heading trigonometry, trigs. Let's do a checklist on what you need to know for trigs. Question number 1, you need to know how to solve a diagram. It's always going to open up with the diagram. You're always going to see a Cartesian plane with a line drawn. Number 2, simplification, reduction, special angles, identities, proving left-hand side equal to right-hand side. Then we have what we call trig substitution, where they tell you if sine 21 equals P, find blah, blah, blah in terms of P. I'm showing you the exact structure of your trigs, how it's going to be asked. It's going to be asked in this order. And then, general solution. Here you got to solve. Diagram, you know, reduction, special angles, your 30, 45, 60-degree angles. Identities, the question will say prove. Substitute, it will say if sine 21 equals P. General solution, it will say solve. So the question will direct you as to what to do. Let's start with the diagram question. Now, whenever you get a diagram, now we're going to go in this order until we master this, 50 marks. All this plus, at the end of the year, you're going to get your trig graphs will be included in this. So probably about 35 to 38 marks on normal trigs and 12 marks on trig functions, trig graphs. Your sine graph, your cos graph, your tan graph. That makes up your 50. So all of this would be about, I would say 35 to 38 marks, maybe 15 marks on that. Oh, then you still got trigs on different planes. So maybe 30, 10 with the one on trigs on different planes. Yes, so let's go a little bit back here. Let's make that 30 here. Then you're going to do the area rule, sine rule, cos rule that you won't do now. You'll do it in term 3. That will give you another 10 marks. And then another 10 marks on your trig graphs. And that makes your 50. So 30 marks on all of this. Okay, we all good? We know the picture now. We know exactly where we're heading. Right, let's start with the first one with the diagram. So let's give you a diagram. Take the diagram down. Take the diagram down. And I give you that. And we tell you that angle there is angle theta. We've got that as your y-axis, that as your x-axis. And they call this, generally that's 0. And usually they'll call this point P. Let's say that's point P. Let's say that's -4 and 5. Right, take this question down. Take this question down and let's ask you questions on this. Right, Question number 1. Find sine theta. No, firstly, they'll ask you for the length of OP. Find the length of OP. Then, find sine theta without the use of a calculator. Then they'll tell you, find the value of sine squared theta minus cos squared theta. And then find angle theta correct to 1 decimal place. Mark allocation here. Remember, this is your checklist on the side. On the side is your checklist to see whether you know trigs. You need to know everything here. You need to know the diagram, need to know reduction, need to know identities, need to know substitution, need to know general solution. And this is all for your June exam. So now you know exactly how much work you got to go and put in when you go home. But the main thing today is making sure that you understand everything. And it's not difficult. Honestly, it's not difficult. You have to apply and you have to learn your rules. Onliners, how are we doing? You love trigs. Okay. Nice. Okay, let's give you mark allocations here. Find OP for 2 marks. Find sine theta, 2 marks. Find the value of this, 3 marks. Find theta, 3 marks. 3, 6, and 4. How many marks here, guys? 10. 10 marks for Mahala. 10 marks for Mahala. Let's answer question number 1. Find OP. The first thing you do is you drop your 90 degrees against your x-axis. That's x, that's y. So this here is -4. That's your x. 5 is your y. We need OP, so we use Pythagoras. OP squared is equal to -4 squared plus 5 squared. OP squared is equal to 16 plus 25. OP squared is equal to 41. OP equals the square root of 41. And there we go. That is the square root of 41. Yes or no? Excellent. Your first 2 marks. Right, onliners? Easy peasy. Easy peasy. You can start already. Start doing sine theta, sine squared minus cos squared, and find theta. You don't need to wait for me. You can carry on, guys. You can carry on. If you know the work, you can carry on. Okay. Lollipop time. Let's answer question number 2. Sine theta. Now, we always work with theta inside our triangle. So we know we use SOHCAHTOA. What do we use? SOHCAHTOA. So sine theta is equal to opposite over hypotenuse. Sine theta is equal to 5 over square root 41. That's it. You leave it like that. They asked you for sine theta. You leave it like that. Question number 3. Sine squared theta minus cos squared theta. Sine squared is 5 over root 41 squared minus cos squared is minus 4 over root 41 squared. So 5 squared is 25 over 41 minus 16 over 41. What is 25 minus 16? 9 over 41. That's your final answer. Agreed, guys? Now find the value of theta. That's easy. After this, we're going to go into reduction. Straight into a past paper. Right. Now to answer question number 4, you can do sine, cos, tan, whichever one you want to use. I'm just going to start off with this one. To answer question number 4, I'm going to just start off with sine theta. You could use cos or tan. So some of you might ask, but sir, why did you use sine? I just used sine because sine was there. I could have used cos or tan. We're finding the same angle. So theta is equal to shift sine 5 over root 41. Shift sine, remember use the shift key when you're looking for an angle. 5 over root 41. 51,34. But that's this angle here. That's 51,3. They want this angle here. So therefore, theta is equal to 180 minus 51,3. Why? Adjacent supplementary, angles on a straight line. 128, they say correct to 1 decimal place, so 128,7. And that's this outside angle, 128,7. And there we go, we're done. There we go, we are done. Now let's give you a 5-mark question. I'm giving you 2 questions, a 5-mark and a 7-mark. With reduction. We're going into reduction, 12 marks. Generally, you'll get one with numerical values like angles and one just with x's and y's. Let's go. Take a deep breath. Onliners, I hope you're ready. Lollipop time. Let's check. I'm erasing this. Right. Are you ready? Simplify without the use of a calculator. The first question is worth 5 marks. Simplify. 3 cos 150 times sine 270 all over tan negative 45 plus cos 600. Now, guys, you have to show how you reduce. You get a mark for that step. You can't cheat here. You can cheat in your last step when you're using your special angles, as long as you don't give decimals. But here in the beginning, you can't cheat at all. You've got to show the reduction. You've got to show how you're reducing it. So this one is worth 5 marks. Those of you who are good, you can start already. Those of you who don't know what's cutting or what's clapping, you can just sit back and enjoy the show. You need to pay attention. Right, let's go. You want me to do it, or you want to give me? You want me to give you 2 minutes to try it on your own? 2 minutes. There is it. 2.5 minutes. 5-mark question. 2.5 minutes. Crack it. Come, give me an answer. Onliners. Go for it, guys. Go for it. No, I'm itching to do it. Let me shut up and wait for you. All right. In fact, let me put up both. Some of you are smart. So do this one and do the next one. tan 180 minus x times sine 90 plus x all over sine minus x minus sine y cos 90 minus y for 7 marks. This one's worth 5, this one's worth 7. 12 marks here on the screen. Yeah, we give you 2 minutes. We give you 2 minutes. No, I lied. 2 and 3. So you got 5 minutes. Do them both. Get them right. You're going to see this in your exam. Basically, it's like we're writing the June exams yesterday and today. It's as if we are writing the June exams now. Know your rules. You should get the first step right. 3 cos 150 is 180 minus 30. Or you can say 180 minus 150. But then you're going to have to do one more additional step afterwards. So I like doing it like this. I already say 180 minus which special angle will give me 150 is 30. Times sine 270. Go to your calculator. Sine 270 is minus 1. All over. Tan of minus 45 is minus tan 45. Plus cos 600 is going to be now 360. 360 is 720. So 2 times 360. Do you want to go 3 times 360? Because it's, if we go 3 revolutions, 360 times 3, no, that's too far out. Let's go 2 times. So the best would be, alternatively, if we just minus 360 from there, 600 minus 1 revolution, 360 is 240. We can if you want. So this is the same as saying let's go 2 times 360. 2 times 360 is 720. 720 minus how much will give me 600? 120. Very good. Okay, so you have to get that step right. Now let's reduce. 3, pay attention. Cos 180, the name stays the same, cos 30. Remember, 180 and 360, the name stays. 90 and 270, the name changes from sine to cos or cos to sine. 180 minus is in my second quadrant. Cos is negative. Multiplied by negative 1 over minus tan 45 is 1 plus cos 360, the name will stay the same, cos 120. Now we still need to reduce that. We still need to reduce the 120. I'm going to move over to the side. Negative times a negative is a positive. 3 cos 30 over minus 1 plus cos 120, we know, is 180 minus 60. Don't use 90 plus 30. Use 180 minus 60 because we want to try and keep the name, not change the name. Now let's reduce that. 3 cos 30 over, we're doing it item for item, step by step. Don't make a mistake anywhere. Minus 1 cos 180 will stay cos 60. 180 minus is in my second quadrant. Cos in my second quadrant is minus. So that is 3. What is cos 30? You can check on your calculator. Sine 60 root 3 over 2. All over 1 minus cos 60. Minus 1 minus cos 60 is a half. Now, so you're left with 3 root 3 over 2 divided by minus 1 minus a half is minus 3 over 2. Now you can clearly see here 3 over 2 and 3 over 2 will cancel out. But don't forget the minus in the front. Positive divided by a negative is a negative. And what are we left with? Square root 3. Final answer. Step by step, item for item. You leave nothing out. Any mistake anywhere here, and it's going to throw you completely out. Onliners, did you get? Nabila, you got negative 3 over root 3. Nomvi, how can you be cooked? You're only starting with trigs now. If you are writing your June exam now, you are cooked. You're playing. You're not supposed to be cooked. You're supposed to be cooking. Maths is fire. Nabila, did you see where you went wrong? Somewhere along the line. Yes. It's fine. You can get it wrong here in class. Just don't get it wrong in your exam. Right, the last one. Are you done with the last one? Or are you still busy? Still busy. Be careful. Negative angle here. Remember, sine of a negative angle minus sine. Tan of a negative angle minus tan. Cos of a negative angle is positive, eh? Cos of a negative angle is always positive. Be careful. I'm erasing the one on the left. Let's do it in your answer. Do it item for item. Do that separate. Do that separate. Do that separate. There's a minus. There's nothing you can do there, and do that separate. Then start putting it all together. Tan 180, the name is going to stay tan x. 180 minus is in your second quadrant. Tan is negative. Times sine 90, the name is going to change to cos x. 90 plus, 90 degrees plus is in your second quadrant. Sine, don't look at the changed one. Look at the original. Sine in your second quadrant is positive. Over. Sine of a negative angle minus sine x. Did you all get that? Onliners, did you all get that? People say they tried, cried, and now fried. Funny. Minus sine y times cos 90 will become sine y. 90 minus is in my first quadrant. Everything's positive. Right, now watch. Negative divided by negative is a positive. Convert everything to sine over to sine and cos. So tan, we all know tan is sine x over cos x, multiplied by cos x over 1, divided by sine x, minus sine y times sine y, sine squared y. Not sine y squared, sine squared y. Now let's simplify. Cos x, sin x, sin x. What are you left with? 1 minus sine squared y. According to your identity, 1 minus sine squared is cos squared y. There's your final answer. How many of you got that one right? Yay! Well done. Well done, well done, well done, well done. You got yourself 7 marks. You got yourself 7 marks. Okay. Do you guys want one more reduction? One more reduction, or must I move on to identities? Are you sure? Okay, one more. Last one. Let's give you one more before we go on to identities. Well done, Zain. Well done, Karabo. Well done, Nabila, how you got one? Muiz, you got it right. Mixo, nice. Lovely. Lovely, guys. Right. Some of you are still taking down the corrections for that one. The rest of you, you can try the next one. Here's the last one in reduction. Sine 180 minus a, take this one down, times tan a, times sine 90 plus a, all over tan 180 plus a, cos negative a, sine negative a. Remember, after reducing, you want to convert everything to sine and cos. After reducing, you want to convert everything to, in its simplest form. Remember, trigonometry in its simplest form is sine and cos. Come, start with this one. Let's see how many marks. Okay, now with identities, I'll start you off with easy. We'll do level 1, level 2, and then I'll throw you with in the deep end with the sharks. After this, we are doing identities. No, in fact, let's do the other one, trig substitution first, where you got to construct a diagram and say if sine 21 equal p, find cos 21, tan squared 21 in terms of p. Or A, or M. You need to know it for grade 11 and 12. Grade 11s, how are we doing? Yuvan, here we go. There we go. Muiz, there's one more for you, bro. Some people are done already. Sine 1/8, this is just testing whether you can reduce. Sine 180 will remain sine A. 180 minus is in your second quadrant. 180 minus, sine is positive. Tan A is sine A over cos A. Sine 90 will change to cos A. 90 plus is in your second quadrant. Sine is positive. That's over 1. Make it over 1, make it over 1. Divided by. Tan 180 will remain tan A. And 180 plus is in your third quadrant. You know ASTC. All students take Coke. All strippers take cash. Oh, sorry, I wasn't supposed to say that. It wasn't me, I didn't say that. Anyway, all positive, sine positive, everything else negative, tan positive, everything else negative, cos positive, everything else negative. All students take Coke. Just remember, the cast diagram. Right. So tan 180 will remain tan A, and that is sine A over cos A. Cos of a negative angle is positive cos of that angle. Sine of a negative angle is minus sine of that angle. Again, they're just testing you in each part. Do you know your rules of reduction? Sorry, Zain. Don't go show your teeth. Don't go and tell your teachers I said all strippers take cash. Right. Cos A, cos A. Cos A, cos A. Sin A times sin A, sine squared A over minus sin A times sin A is sine squared A. That and that cancels out. Your answer is -1. Did you guys all get that one right? Onliners, did you get -1? There's 5 to 6 marks for you again. On-siters, got it right. Well done. Well done, well done, well done. Okay, let's throw you in. Oh, okay, Nabila. Oh, yeah, that's the safer one. Thanks, Nabila. So Nabila says, no, we should have said add sugar to coffee. Okay, okay, okay. Here's it, here's it. Here's my sugars. Here's my sugars. Yeah, let's go. Well done. At least you guys listening and paying attention. That's excellent. All right. Now watch here. Now, if they told you if sine 21 equals m, find question number 1, cos 21. Question number 2, sine squared 21 plus cos squared 21. Number 3, tan 159 in terms of m. Mark allocation, 2 marks. 3 marks. 3 marks. Total marks 8. Now, how do we do this, guys? Question, answer. Now, I'm going to show you a little acronym, my own little study note for this. Whenever you see this, now pay attention, guys. You use what I call scrap, the method, the mental method, I call it scrap. What do? You scrap it. Right, what does it mean? S for standard form and SOHCAHTOA. Pay attention. Don't write. C, that's step number 1. Put this in standard form and use SOHCAHTOA. Step number 2, these are your steps. S for standard form and SOHCAHTOA. C for Cartesian plane. Draw your Cartesian plane. R, look for a restriction if they give you. A is just for and, don't worry about A. And P, use Pythagoras to finish it. So whenever we need to draw a diagram, we use this mental method called scrap. So let's follow this mental method, guys. Standard form, the right-hand side must be a fraction. So put it in your answer, say sine 21 equals m over 1. Standard form. SOHCAHTOA, sine is opposite over hypotenuse. Yes or no? Guys, are you following? Right, what's the next thing I need to do? Right, draw your Cartesian plane. And if they don't, now we look for a restriction. They don't give us a restriction. So just draw it in your first quadrant. 21 degrees is there. That's your reference angle. Opposite over hypotenuse, m over 1. Now we're going to use Pythagoras to finish it to solve for x. So 1 squared equals x squared plus m squared, Pythag. This is Pythag. 1 minus m squared equals x squared. So x is equal to the square root of 1 minus m squared. So we know that thus x here at the bottom is, what is it? The square root of? Correct. You have to do the diagram first. You have to do the diagram first. Now, we start answering the questions. All in turn. We're using that diagram to answer all these questions, and we're going to get full marks for it. Onliners, are you on fire? Are you cooking, onliners? Are you locked in? Let's answer question number 1. Now we just use SOHCAHTOA. Cos 21 is what? Adjacent over hypotenuse. Adjacent over hypotenuse, square root of 1 minus m squared over 1, which is the square root of 1 minus m squared. Number 2, sine squared 21 minus cos squared 21. Sine 21 is m squared. Minus cos 21 is the square root of 1 minus m squared. That was cos 21 squared. That and that will cancel out. You're left with, pay attention, m squared minus 1 minus m squared minus 1 plus m squared. What is 1m squared plus 1m squared? 2. Oh, plus. Oops. Oops. Okay, plus. Let's go back. Sorry. All right, let's go back. So that gives you, I'm thinking of grade 12. We did so many grade 12 workshop because sine squared minus cos squared is a grade 12 one. So m squared plus 1 minus m squared. We don't need to put in, the positive doesn't change the brackets. M squared plus 1 minus m squared. M squared minus m squared is 0. And we know, we've just proved the identity that sine squared of an angle plus cos squared of the same angle is equal to how much? 1. Do the last one, 10, 159. What is the relationship between 159 and 21? Reduction. Very good. 180 minus 21. So do it. You have to reduce this. You have to look for the relationship between the angle they gave you and your reference angle and a quadrant. Let's do the last one. tan 159 is equal to tan, let's reduce that, 180 minus 21. That will give me minus tan 21. That is minus tan 21. That's not a minus there, that's just m. So that's minus tan 21 is m over the square root of 1 minus m squared. Opposite over adjacent. From soccer. Done. Finish. You got your full marks there. Right. Let's go into identities. Let's go into identities. Right. Guys, I'm going to give you a level 1, level 2, level 3. We're going to do 3 identities, right? 3 identities. Now, I'm going to show you an art of doing, like I showed you an art of doing this scrap. Don't forget scrap. Standard form SOHCAHTOA, Cartesian plane, restriction if there is one, then you draw it in the right quadrant, and A for n, and you must use Pythagoras to finish it. Agreed, grade 11s? We all talking the same language? Good. Right. Put the heading identities. Now we know in identities that sine squared of an angle plus cos squared of an angle is equal to 1. Yes or no? Sine plus cos is sine plus cos. But sine squared plus cos squared is equal to 1. What time? All right, 12:30. So we got 30 minutes, guys. Food and beverage will be provided for you on site. So you are getting lunch. Okay. And remember, tan squared of an angle is equal to sine squared of an angle over cos squared of an angle. Now we also know from this identity, pay attention, that sine squared is equal to 1 minus cos squared, which is also the difference of 2 squares. And we also know that cos squared is equal to 1 minus sine squared, which is also the difference of 2 squares. Good to know this. We're going to be using it. Derive from here. These are your identities. Right. You all got this down, right? Okay. Now let me show you an art of identity. Remember here we have to prove left-hand side equal to right-hand side. We're going to convert them to sine and cos in its simplest form. Identities is like identical twins. If I got a pair of twins, right? And the one brother, 2 brothers, and the one comes from war, and he's got his boots on, he's got his jacket, he's got his backpack, he's got everything on. The other brother is in his boxer shorts. Now we need to prove that the 2 are identical. Obviously, it will be easier for us to undress the one, to tell me, hey, get into your boxer shorts. The 2 of you, we know you are the same. So what is the clothing in mathematics? Is your brackets. Your clothing is your brackets, your third sign, so you want to remove the algebra. So hence, listen to me, for identities we use, watch here, watch here, watch here, if you want to get all your identities right in your exam. For identities, we use the acronym ALI. I'll tell you what ALI stands. Who does identities? Who does, hey, grade 11s, who does identities? ALI. ALI does identities. What does? It's just your steps. Step number 1, do algebra. Step number 2, look for your identity. The problem will work itself out. Left-hand side will equal to right-hand side. So AL for algebra. I for identity. So step number 1, do your algebra. Step number 2, look for your identities. That's step number 1. Step number 2, look for your identity. Ali does identities. Now I'm going to use this for our questions, and you're going to see how everything just works itself out. Okay, onliners, Ali does identities. Okay. Now you ought to have seen the next one before. Prove. Right, put your pens down. Prove that sine x plus cos x all squared equals 1 plus 2 sine x cos x. For 4 marks. Question, answer. Right, pay attention. We start on the left-hand side because this is the side that got brackets. It's got clothing. We want to put it into its boxer shorts, sine and cos. Agreed? Let's do the algebra. Pay attention. Sine x plus cos x all squared. Isn't this algebra? In algebra, let's do AL. Step number 1, AL from Ali. Ali does identities. Let's do the algebra. If I have to remove brackets, this is A plus B all squared. What will this be? A squared plus 2AB plus B squared. Yes or no? So what's the square the first term? Sine squared x. Square the second term? Plus cos squared x. Multiply the 2 inside the brackets and times it by 2. Plus 2 sine x cos x. Yes or no? There's it. Step number 1, algebra. What's step number 2, guys? Look for your identity. Is there an identity there? Sine squared plus cos squared is how much? 1 plus 2 sine x cos x. Left-hand side is equal to right-hand side. Left-hand side is equal to your right-hand side. So Ali does identities. I'm going to give you another one. You should have seen it in school before. Agreed? Those of you who are done with this one, you can start with the next one already. Right. 1 over 1 plus sine x plus 1 over 1 minus sine x is equal to 2 over cos squared x. For 4 marks. Prove. Do the algebra first. Do the algebra first. Start on the left-hand side. 12:30 is break, guys. 12:30 is break. Oh, the next one's a killer. The next one is a killer. So like I said, I'm giving you, we're going up in graded questions. Yeah. We're going to do the next one, and we got some general solution where you're solving for x. Who's done here? Left-hand side. Onliners, did it work out? Onliners, did it work out? Right, let's start on the left-hand side. Let's do the algebra. We are adding 2 fractions. So what must I do in algebra? Guys, what must I do in algebra? Lowest common denominator, LCD, am I right? So what is my LCD? 1 plus sine x into 1 minus sine x. Are you all paying attention? We're doing the LCD, lowest common denominator. Pay attention, guys. You need to know this. So now, 1 plus sine x, 1 plus sine x will cancel. What are you left with? 1 minus sine x, right? 1 minus sine x times 1 is 1 minus sine x plus 1 minus sine x, 1 minus sine x will cancel out. What am I left with? 1 plus sine x. 1 plus sine x times 1 is 1 plus sine x. Now my algebra is not yet done. Minus sine x plus sine x is 0. 1 plus 1, grade 11s. So clever. 1 plus 1 is 2 over. To remove the brackets here, that's the difference of two squares. 1 times 1 is 1, minus sine times sine is what? Sine squared x. There we go. I'm done with the algebra. I am done with the algebra. Now look for your identity. 1 minus sine squared is what? There we go. 1 minus sine squared. So now we do. Ali does identities. We're done with the algebra. Let's look for the identity. 2 over cos squared x, which is equal to your right-hand side. Well done, Mahdia. Well done, Muaz. Well done, Tala. Well done, Juve. Did it all work out for you guys? Left-hand side worked out to right-hand side. Are you ready for the killer one? Are you ready to die? Good. Well done, onliners. Well done, on-siters. Right, let's throw you into the deep end. Get ready. The next one is ugly. But just follow algebra, guys. Do BODMAS. Remember, we always follow BODMAS. Brackets first. Brackets, division, multiplication, addition, and subtraction. Get ready. Take a deep breath. Clear your mind. Clear your mind. The next one's a killer. Are you ready? Give it to us. You love a good challenge. Nice. So here comes from a past paper. A final exam grade 11 past paper. Here goes. Proof. Tan squared theta minus sine squared theta into cos squared theta over sine squared theta plus 1 all over tan squared theta equals 1. 7 marks. Come, guys. Pay attention. Nice. I'll give you 5 minutes. I'll give you 5 minutes to do this one. I'm going for an oxygen break. Oxygen. Where's Hassanin? I'm giving you guys 5 minutes. 5 minutes. Are you out? Did you get it? Okay, we are back. Let's go. Left-hand side. Now, this side is loaded. So we need to unload it. We need to unpack it. Right. Tan squared. Tan squared is sine squared theta over cos squared theta minus sine squared theta over 1 into. Now that's 1 over 1. My lowest common denominator there in that bracket is sine squared theta. Right. So sine squared into sine squared once. 1 times cos squared theta is cos squared theta plus 1 into sine squared times. Sine squared times 1 is sine squared theta. Now we're not yet done. Let's sort out the algebra. On this side here, so there's your brackets. LCD in this bracket is cos squared theta. Cos squared into cos squared once. 1 times sine squared is sine squared. Minus 1 into cos squared times. Cos squared times sine squared is sine squared theta cos squared theta. Sine squared plus cos squared in that bracket is 1 over sine squared theta. We're not yet done with the algebra. Here, highest common factor is sine squared theta. We're left with 1 minus cos squared theta over cos squared theta times 1 over sine squared theta. We're not yet done. We're left with sine squared theta into 1 minus cos squared is also sine squared theta over cos squared theta multiplied by 1 over sine squared theta. Now we are multiplying and dividing. Now we are multiplying and dividing. Hey, what's happening here? No. Why do we get 1? What happened here? Because, no, it doesn't get 1 because that and that cancel. Sine squared over cos squared is tan squared. Oh, we forgot over tan squared. Oh my God. Okay. Relax. Okay, I'm going to do this. I'm going to say divided by tan squared is sine squared theta over cos squared theta divided by sine squared theta over cos squared theta divided by sine squared theta over cos squared theta. Okay. So here we go. Now we have to still say on this side, divided by sine squared theta over cos squared theta. We forgot that denominator there. Here's your answer coming up. Sine squared. Now, divided by, so now you left on the left-hand side, you are left with, I'm just going to do it in blue, sine squared theta over cos squared theta, and times, multiply by cos squared theta over sine squared theta. Here's your final answer coming up. That and that cancels. What's your answer? Which is equal to your right-hand side. There we go. We forgot that. There we go. I just moved it to the side. In fact, we would have had to do that from the start. In any case, when you have a fraction over a fraction, just move the fraction to the side and then tip and times. It's easier to work because you don't want to work with a fraction over a fraction. Agreed? Onliners? Thanks. There we go. Lovely question. But we got it. We got it. We got it. We forgot about the 10 on the left-hand side. Yes, but we got it. Nice question. Nice question. Let's see if there's another. Maybe I can do one more for you, and that will take us almost into break. It's already 20 past 12. We've got like 10 minutes. We'll come back. We'll do general solution. After break, we'll do general solution, and we go straight into Euclidean. So let's give you one more identity. Let's give you one more identity. You 9 marks for the next one, brah. Sure. Okay. Okay. I've never seen a 9-mark question in a long time. One question, 9 marks. 1 minus 2 sine squared A over 1 plus 2 sine A cos A is equal to 1 minus tan A over 1 plus tan A. Prove. Prove the left-hand side equal to right-hand side. Convert everything to sine and cos. 9 marks. I'll even tell you which paper this one came out of. They don't tell you. Anyway, there we go. Crack it. Come on, liners. Show me what you got. Nice. Come on, liners. Last one. Last one before break. Last one. You have to practice on these, guys. You need to practice. Shh. Come, grade 11s. This one is taking us to break. We got 7 minutes. I'll give you 2 more minutes and then I'll do it for you. I'll give you 2 more minutes and then I'll do it for you. This will take us straight into break. After break, we do general solution. Guys, in this one here, we have to work on the left-hand side and we have to do the right-hand side. Because this is not in its simplest form and that is not in its simplest form. You've got to work with both sides. At the end, the two, left-hand side must equal to right-hand side. Here, you're not only working, you work with the one side till you can't sort it anymore. Then you work on the other side until you can't sort it anymore. The minute they are in terms of sine and cos, in its simplest form, left-hand side will equal to right-hand side. Come, guys. Who's battling? Okay, clever question. Okay, I know exactly what to do. Come on, liners. How are we going to get something from the numerator to cancel out with something in the denominator? Right, let me teach you a little trick. Make them both quadratic equations. How? Let me show you. The number one is sine squared theta, sine squared a, is sine squared a, the number one is sine squared a plus cos squared a, that's 1, minus 2 sine squared a. All over. The number one is sine squared a plus cos squared a plus 2 sine a cos a. Now, 1 sine squared a minus 2 sine squared a. So you got cos squared a minus 1 sine squared a. 1 minus 2 is minus 1. All over, I can put cos squared a plus 2 sine a cos a plus, I'm just moving this to the back, plus sine squared a. Right. Now cos squared a minus sine squared a, cos squared a minus sine squared a is the difference of two squares. So that is cos a, watch, cos a minus sine a into cos a plus sine a all over. Now this is a trinomial. This here is cos a plus sine a into cos a plus sine a. Because cos times cos is cos squared. Sine times sine is sine squared. 1 sine a cos a plus another 1 sine a cos a will give me my plus 2 sine a cos a in the middle. Now that and that will cancel out. So you are only left with that. There's nothing you can do with that any further. Now let's go to the right hand side. 1 minus 10a. Watch here. 1 over 1 minus 10a. 10a is sine a over cos a divided by this is going to be 1 over 1 plus 10a sine a over cos a. Okay, we use square brackets. Let's use square brackets. This is equal to, let's do LCD in here. Common denominator here is cos a. 1 into cos, cos times. Cos times 1 is cos a minus cos into cos once. 1 times sine a is sine a divided by, let's do the LCD here, cos a. 1 into cos, cos times 1 is cos a plus cos into cos once. 1 times sine a is, right, now tip and times. Tip and times. So you're going to have cos a minus sine a over cos a multiply by, flip the side around, cos a over cos a plus sine a. Here's our answer coming up. Cos a and cos a cancels out. Numerator times numerator, cos a minus sine a. That's what I want. There we go. All over 1 times that, you're left with cos a plus sine a. That's what we want. Therefore, left-hand side is equal to right-hand side. 12:30 on the dot. Kwaine? Quine.
Well done, Mr. Khota.
Quine.
So learners, just a note, your burgers are on
What
their
a
way.
question, guys. What a question.
Your burgers are on their way. They will be here in the next 10 minutes, so just hang 10. Don't go and buy slap chips and fish. We got you here with a nice burger.
Guys, go over this. Remember, it's recorded. You can watch this over and over and over until you get the full marks for this. Guys, we're going on for break now. Hope you guys enjoyed our second session. We got the last session. You don't want to miss it. General solution and Euclidean geometry. Enjoy your break, guys. Enjoy. Remember, what time are we coming back? 1:15. 1:15. Guys, we are back at 1:15. We are back at 1:15. Okay. Why they put they will resume at 11 a.m. What's coming up there? Okay. We are back. Let me make sure my phone is on silent here. There we go. Phone's on silent. Okay, grade 11s, we are back. Onliners, are we there? Hello, onliners. Did you guys enjoy your break? Is everybody back? Are your tanks full? No, not yet. Last session for this weekend, guys. It's been an amazing weekend. An entire weekend that we spent doing math. What a way to spend the weekend, guys, in the mother city and with all the learners nationally across South Africa. Onliners, how are we doing? How are we doing, onliners? Welcome back. Yo, you guys are not playing. You guys are on fire, bruh. You guys are on fire. Okay, so we ended up with this identity, with this heavy identity, where we had to work with our left-hand side separately. We had to work with our right-hand side separately. And finally, in our final answer, the left-hand side was equal to the right-hand side. Okay, we're coming towards the end of... Sure, here we go. We're coming to the end of trigonometry, guys. Okay, so let's erase that. Let's start now with general solution. So put the heading general solution. Now there are various forms of general solution. For sine, it's your angle plus k times 360, where k is an element of integers. That's for positive sign. Or you're going to say 180 minus your angle plus k times 360. For sine, you must give 2. And if it's for negative sign, you got to say 180 plus, or you got to say 360 minus. I'll explain to you this when we do it. So just remember, you got 3 general solutions. One for sine. For cos, you say plus minus your angle plus k times 360, where k is an element of integers. So for sine and cos, it's plus k times 360. For tan, your general solution is your angle plus k times 180, where k is an element of integers. So that's sine, that's cos, and that's tan. Okay. Now let me explain to you what this means. Take this down. This is what we call general solution, where we are solving for theta or solving for x. You get for sine, for cos, and for tan. Now, why is sine and cos plus k times 360? Because we know that a full sine graph makes its appearance every 360 degrees, and a full cos graph makes its appearance every 360. A full tan graph makes its appearance every 180 degrees. So take this down, guys. I'll explain to you this. We're going to do a couple of examples, about 4 or 5 examples, maybe more, just to show you how general solution is done. So get into it. Time to lock in. Time to strap yourselves up. Take out your calculators. Take out your scientific calculators, get your stationery, get your books, get everything ready. I'll show you how to crack general solution. Right. I'll start off with the easiest one. Shh, guys. Okay, so you've got your general solution. One for sine, one for cos, one for tan. Sine and cos plus k times 360, tan plus k times 180. You all got that? Excellent. Onliners, we good to go? Can we start working? Can we start? Can I clear the frame? I'm sure you all have got it down by now. Okay. Let's start off with the sine one. Very, very, very easy one. Let's start off with question. Now, you're not going to see something so easy, but I'm just showing you how it's done. So let's say 3 sine x minus 1 equals 0. And x is an element of 0 to 360. Right, solve for x. Now I'm going to pick you up in levels of difficulty. So we're going to start off with the easy one, and then we're going to move up to some crazy ones. But they're all done with the same thought process in mind. Few of them, there's certain glitches, there's certain techniques that you have to apply. So what you want to do here, guys, pay attention. Remember, I gave you an acronym for drawing. We said SCRAP. Do you remember SCRAP? Standard form, Cartesian plane, restriction, and Pythagoras. Who does identities? Ali does identities. What does AL stand for? Algebra. What does I stand for? Identity. Now, for general solution, I'm going to give you a new acronym. I'm going to give you a new acronym. SSGR. You can make up anything you want to with it. Stupid students get rabies. I don't know, whatever you want to do. Right. The first S is you want to get it into standard form. You want to get that into standard form. Then you want to use the shift key on your calculator to get your angle. Then you want to attach your G for general solution. And R, your restriction. So this is how we do it, SSGR. So general solution, we use SSGR. Right, Muiz? Right, Muaz? Right, Tala? Karabo? Farhan? Okay, let's go. Now pay attention. Right, put down your pens. Let's get this into standard form first. S, the first S, standard form. So you're going to say 3 sine x is equal to 1. Sine x is equal to 1 over 3. Yes or no? Your right-hand side must be a fraction, and the coefficient of your trig function must be 1. Are you all following me, grade 11s? Right. So that's step number 1, the first S. What's the second S? What's the second S? Use the shift key. So x is equal to shift sine a third. Go to your calculator. Shift sine 1 over 3. 19,47. Let's call it 19,5. Yes or no? So we use the shift key to solve for the angle. Right, grade 11s? What's the next thing we need to do? Attach our general solution. So what's your general solution for sine? Plus k times 360, where k is an element of integers. Or, now let's look at our restriction. They said 0 to 360. So where is sine positive? This is quadrant 1. Or where else is sine positive? Where's sine positive? Sine is positive there and sine is positive there. Yes or no? So, or x is equal to 180 minus. If an angle lies here, 180 minus. 19,5 plus k times 360, where k is an element of integers. So you give both quadrants, quadrant 1 or quadrant 2. So here's your first answer, 19,5, or x is equal to 180 minus 19,5, 161,5, or 160,5, plus k times 360, where k is an element of integers. These are your two solutions, 19,5 or 160,5. Are you all with me? Yes, Ayman. Also 180 minus. Excellent. Your reference angle is 19,47 or 19,5. I just rounded it off to 1 decimal place. Now pay attention. Pay very careful attention to these general solutions. Pay very careful attention. What if I made this plus? Watch here. I'm changing it. I'm now into example number 2. What if I change this to a plus? That means that must become a minus and that must become a minus. Yes or no? All right, now pay attention. Now pay attention. Here's a little trick. There's a small glitch here because it's negative now. So SSGR. Right, let's do this one together. All right, so in your answer, you're going to get that as minus 1 over 3. So x is equal to, right, shift sign 1 over 3. Ignore the negative. The negative is just going to indicate the quadrants. Where is sign negative? Quadrant 3 and quadrant 4, yes or no? So what is shift sign a third? What did we get? 19,5, am I right? Be careful. So put 19,5 plus k times 360, where k is an element of integers. Now you need to give an answer for quadrant 3 and you need to give an answer for quadrant 4. So quadrant 3, x is equal to 180 plus, and quadrant 4, x is equal to 360 minus. So now we say 19,5 plus k times 360, where k is an element of integers. So x will equal 180 plus, that's 199,5 plus k times 360. And your other general solution, 360 minus 19,5 plus k times 360, where k is an element of integers. So x is equal to 360 minus 19,5 equals, we get 340,5 plus k times 360, where k is an element of integers. Are you all with me? Learn this. And what if, just watch here, I'm just doing this here in red. What if your restriction was x was an element of minus 360 to plus 360? Pay attention. Then you're going to have to put in all your integers. After you do this, now you say 199,5 plus 0 times 360 plus 1 times 360 minus 1, where k is an element of integers. So what are your integers? 0, 1, 2, minus 1, minus 2. Whichever of these integers here fall within your restriction, those will be your possible solutions. And you'll do the same here. 340,5 plus 0 times 360 plus 1 plus 2. 340,5 minus 1 times 360 minus 2. Again, whichever of your final answers. You do that substituting last. When do you do the substituting of integers? Last. We all okay? This was the sine one. This was the sine one. Let's give the general solution for cos. Let's give the general solution. Oh, let's do one in terms of tan. Then we'll do one in terms of cos. So that's sine. Is it 350,3? Oh, yes. 360. No. 360 minus 19,5 is 340,3, 5. Ayman. 360 minus 19,5, not minus 9,5. Okay, let's do one in terms of 10. Now 10, you only give one general solution. So let's say, here's another example in the exam. If 2, 10, x minus 8 equals 0, x is an element of 0 to 360. Right, answer, SSGR. SSGR. So that means 2, 10x will equal to 8. 10x will equal to 8 over 2. 10x will equal to 4. X will equal to shift 10, 4. Shift 10, 4. 75,96. Shift 10, 4. Yeah, 75,96. So 75,96 plus k times 180, where k is an element of integers. There we go. We're done. We all okay? You don't need to give 2. Because the minute you start substituting in here, now they give you a restriction. So now you can say plus 1 times 180. Or, remember, where is 10 positive? Because they gave you a restriction. If they didn't give you, let's say they didn't give you a restriction, that would be your final answer. But the minute they give you a restriction, x is an element of 0 to 360. Now, where is 10 positive? 10 is positive there or there. So this is quadrant 1 answer. What is here? Quadrant 2. X will equal to, because 1 times 180 is 180 plus 75. So 180 plus 75,96 plus k times 180, where k is an element of integers. So your two solutions in there, between 0 and 360, your one answer is 75,96. Your other answer is 180 plus 75, 255,96, 255,96. These are your two solutions. That's between, in this restriction. In that restriction, these are your two answers. That's your one answer. That's your other answer. Okay. Right. Let's pick up the pace. Let's pick up the pace. So these are your simple ones. Right. What if I told you, now pay attention. Now pay attention. Let's say, so here's another one, right? Let's say 3 over 5 shift sine 0,6. Yeah. So 3 over 5. 5 sine 2x minus 10 degrees minus 2 equals 0. And x is an element of 0 to 360 degrees. Solve for x. The question here will say solve for x. Normally, if the restriction wasn't given, it would say give the general solution. Or we could just say give the general solution. Right, give the general solution. Let's say, give the general solution. Give the general solution. So in your answer, it's worth 6 marks in your exam. It's worth 6 marks in your exam. Right. Okay, so we got 5 sine 2x minus 10 equals 2. So sine 2x minus 10 equals 2 over 5. Now, guys, understand something. That's your angle. That's your angle. So your angle is equal to, Now shift sign 2 over 5. Go to your calculator. Shift sign 2 over 5. Shift sign 2 over 5. 2 over 5. 23,57. Can we call it 23,6? Right? So let's see. 23,6 plus k times 360, where k is an element of integers. That's quadrant 1. And then quadrant 2, where is sign positive? Your angle is equal to 180 minus 23,6 plus k times 360, where k is an element of integers. But wait, what's your angle? What's your angle? What is your angle, guys? 2x minus 10, am I right? Isn't that your angle? So now 2x minus 10 is equal to that, or 2x minus 10 is equal to that. Are you guys with me? Are you following? Now we solve for x. Now only do you solve for x. So let's solve for x. 2x will equal to 23,6 plus 10, 33,6 plus k times 360, where k is an element of integers. So x will equal to 33,6 divided by 2. Be careful now. Put your pens down. Put your pens down. Pay attention. We're dividing by 2. We divide by 2, we get 16,8 plus k times, when we divide or multiply x, it affects our general solution. So 360 divided by 2 is how much? 180, where k is an element of integers. And let's do this one here. 2x is equal to 180 minus 23,6. 180 minus 23,6 plus 10. 166,4 plus k times 360, where k is an element of integers. So x is equal to 166,4 divided by 2, 83,2 plus k times 3, 180, where k is an element of integers. There's your solutions. You'll get 6 marks for this. Learn. I beg you guys, learn this. We just found out that one of the top students here at SP last year was also part of the program. Very bright student. Very, very, very bright student. I'm sure SP learners, you know Adrian, who was here at the school in grade 12 last year. Aiden. Was it Aiden? Aiden, ne? I remember Aiden. Aiden used to sit right here in front.
Mr. Khota, you changed the whole
I
subject
changed
here,
all the
man.
names. Bruh, man, there's so many names.
What's the principal of the school called? Can you see?
Fadia.
Got you now.
Mem
Please,
Fadia.
respect the names, man.
Mem Fadia. Aiden. And he got 100% last year. Right, Mr. Charles? On his report, what was his mark? 100%. Total, grade 12, total. Studying maths and stats at UCT, right? Beautiful. Right. Now watch this. Watch this. Give the general, so that's now working with angles. What if they told you to give the general solution of this? Sine squared x is equal to sine x cos x. Give the general solution for 6 marks. Give the general solution for 6 marks. Guys, learn all these different styles. Right? There's one more style after this. What you want to do, you want to get it in a straight line. So they could ask you this question, or they could ask it to you like this: sine squared x over cos x is equal to sine x. You do the same thing. You just make that over 1 and you cross multiply. It will end up looking like that, if they had to give it to you in that format. So don't panic in the exam. You want to get it in a straight line. Now what do we do, guys? Grade 11s, what do we do? Sorry? Anybody? Onliners, what do we do here? No. No. Watch. Sine squared x minus sine x cos x equals 0. What's your highest common factor here? Sine x. What's left over? Sine x minus cos x equals 0. Yes or no? So I got two factors equal to 0. I got two factors. So I got sine x equals 0, or sine x minus cos x equals 0. X is equal to shift sine 0 is 0 degrees plus k times 360, where k is an element of integers, or quadrant 2, x is equal to 180 plus k times 360, where k is an element of integers. That's the one side. On this side, what do we do? What do we do on this side, guys? We need to give the general solution here. Take the cos on the other side. Sine x is equal to cos x. Now what do we do? Divide this side by cos x. Divide that side by cos x. Cos divided by cos is 1. What is sine over cos? Tan x equal 1. X equals shift tan 1, 45 degrees plus k times, for tan, 180, where k is an element of integers. You'll get 6 marks for that. Learn. Know this. Onliners, common factor. Yes, Nabila. Lawrence as well. Okay. All right. I'm going to give you one more style. I'm going to give you one more style. I'm going to give you one more style of general solution. Check the next one out. Now, the next one is very common for grade 11 and 12. It could also be where two graphs intersect, and you need to find the points of intersection of those two graphs, but you got to do it algebraically. You got to do it by general solution. So let's say, pay attention, let's say your one graph was, let's say f of x was sine x minus 30, and let's say your other graph, say this was f of x, and let's say g of x was equal to cos 2x. Right. Give me the general solution for 5 marks. Find the points of intersection of these two graphs. Let's say that was f of x equal to g of x. Right. Solve for x and give the general solution. That's where graph f is equal to graph g. For example, you know this is a sine graph with a shift 30 degrees to the right, and that's cos 2x, where your period is divided, 360 divided by 2, which is 180. But now find the points of intersection. You have to do it algebraically. So solve for x there. How are you going to solve for x in that? And you need to know this for grade 11 and 12. You need to know this for grade 11 and 12. Onliners, what do we do there? What do we do there? While you're doing that, While some of you are cracking that, let me pull out some Euclidean. Okay. We'll start off easy. We'll go into some, but not too crazy ones. Remember, you're still grade 11. Yes, Sibabalwe, Mbongo. Co-function cos to sine. Well done. So this is what you do. Guys, you always change the cos to sine. Pay attention. Now watch. It's done in a certain manner. It's done in a certain process. It's done in a certain art. There's a way of doing it. There is a way of doing it. So let me show you how it's done. Pay attention. So you're going to say sine x minus 30 is equal to change cos to sine. Don't change sine to cos. Change cos to sine. Sine 90 minus 2x. Isn't sine 90 by law of reduction? Sine 90 will change to cos 2x. You agree? Right. That's step number 1. Pay attention. Pay attention. Don't write. Don't write. Pay attention. So step number 1, change cos to sine. Let's write it here on the side. Change cos to sine. That's step number 1. Step number 2, cancel the two signs. Cancel sine. Watch here. Watch. Put your pens down. Sine and sine cancel. Now give your two general solutions. Wait. Pay attention. Now give your two general solutions. Watch. X minus 30. This is for quadrant 1. X minus 30 is equal to 90 minus 2x plus k times 360, where k is an element of integers, or quadrant 2. X minus 30 is equal to 180. Remember, quadrant 2 is 180 minus. Yes or no? Quadrant 2 is 180 minus. So 180 minus the whole angle, 90 minus 2x plus k times 360. You'll do it exactly the way I answer it on the screen. Now solve for x. Now let's solve for x. So x plus 2x is what? 3x. 90 plus 30 is how much? 120 plus k times 360, or 360k, where k is an element of integers. So x will equal to 120 divided by 3 is 40 degrees. Plus k times 360 divided by 3 is how much? 120, where k is an element of integers. That's your first general solution. Now let's do your second one. X minus 30, let's remove the brackets here. 180 minus 90 plus 2x plus k times 360, where k is an element of integers. Now x plus 2x will come on the other side as minus 2x. X minus 2x is minus x. 180 minus 90 is 90. 90 plus 30 is 120. Plus k times 360, where k is an element of integers. So x now is equal, divide by negative, minus 120 minus k times 360, where k is an element of integers. There we go. Quadrant 1, quadrant 2. That's how we do it. Change the cos to sine. Cancel the two signs, and then give your two general solutions. So it's done in 3 parts. Yes, Amen. Perfect. Now, why 90 minus x minus 30? No, you're not, Amen, do not change. Amen. Don't change the cos to sine. Don't change the sine to cos. Change the cos to sine. You'll thank me. Thank you. I'm not saying it's wrong. I'm just saying let's all use one strategy. Change the cos to sine. Don't change the sine to cos. And you see, Ayman, you see, that's why I didn't want you to change the sine to cos, because you see, you made a mistake there already. You said that sine x minus 30 is sine 90 minus. No, it's cos 90 minus x minus 30. But in any case, let's not go into that now. Change the cos to sine. You safe. Play safe. Agreed? It will be about 5 to 6 marks. Probably 3 marks here on the top and 3 marks here at the bottom. Okay? Okay, that brings us to the end of general solution. That brings us to the end of general solution. Okay, let's now go into Euclidean. Now, guys, I'm not going to go, I'm sure by now you all know your theorems. Or must I go through the theorems with you? Huh? I mean, there's 11 theorems. By the time we get done with, okay, you want me to do the theorems? I'll do it with you. Or do you want me to do application of the theorems? Application. All right. Quickly, let's just go through the theorems. I'm not going to go and explain each one to you. Everybody has started Euclidean at school. Right? I don't think there's anybody here who hasn't started Euclidean at school. Who hasn't started Euclidean here? Onliners, please tell me you guys have all started. We're 1 week away from the exams. No worry. Okay, good. Let's start. Right, a recap. I'm just doing a recap. The first theorem, that you don't need to take all this down, please. Otherwise, you're going to be wasting a lot of time. The first one we know is a cyclic quad. Yes or no? What do we know about a cyclic quad? Opposite angles are supplementary. And we know that the exterior angle is equal to the interior opposite. Yes or no? Second one. When we have the bow tie or the butterfly or the scissor, where all 4 points touch the circumference, angles in the same segment, yes or no, are equal. Okay. The next one, very important one. Who remembers this one? Equal chords subtend equal angles at the circumference. The next one. Very important, and this one you need to know the proof of it. Line drawn from center of a circle to midpoint of a chord meets it at, is perpendicular to the chord or meets it at 90 degrees. Agreed? Right. The next one. You must have all these shapes in your head already. You must have these shapes in your mind already. The next one. When you have that, like a spearhead shape, asachai, exterior angle at center is 2 times angle at circumference. Or it could also look like this. It could be a quadrilateral from the center going like this. That's also exterior angle at center equal 2 times angle at circumference. Then we have the scissor that starts from the center of the circle, or the bow tie that starts from the center of the circle. Here, angle at center, the internal angle at center is 2 times angle at circumference. Good. I'm just refreshing your memory. I'm jogging your memory so that when we start applying, you know what I'm talking about. So exterior angle equal to interior opposite. Opposite angles are supplementary. They add up to 180. Angles in the same segment at the circumference are equal. Equal chords subtend equal angles. Line drawn from center of circle to midpoint of a chord is perpendicular to the chord, meets it at 90 degrees. Exterior angle at center is 2 times angle at circumference. Same thing here. Outside angle here at the center is 2 times angle at circumference. And this here, internal angle at center is 2 times. So if that's 20, that will be 40. Yes or no? Good. We're not yet done. The next one. A diameter, angle in a semicircle. Angle in a semicircle. So a diameter subtends 90 degrees at the circumference. Always a diameter, if O is the center of the circle, will subtend 90 degrees. What's the next one? A radius or a diameter. A radius or a diameter is always 90 degrees to a tangent. That's a tangent. That's a radius. The next one, very important, you've got to know the proof of it. If I've got a cyclic triangle, that means all 3 points touch the circumference. Then we know that angle between tangent and chord, this is called the tan-chord theorem. What is this called? Tan-chord theorem. Angle between tangent and chord is equal to the angle subtended in the alternate segment. Yes or no? So we know that this angle here on this side here is equal to that angle at the circumference. Tan-chord theorem. And the last one. I'm sure your teachers have given these formulas to you. It's in your textbooks. There are thousands of summaries of these 11 or 12 that you... But just know the picture in your head, because you don't have these theorems in your exam. So you got to know them in order to... And the last one, two tangents meeting at a common point outside the circle. Two tangents meeting at a common point outside the circle are equal in length to where they touch the circle, to the point of contact. There we go. And those are your theorem. Now you must also know your parallel lines, co-interior, corresponding, alternate. Also know we're dealing with radii. Radii make isosceles triangles. What do radii make? Isosceles triangles. So always look for isosceles triangles. Yes, we'll get there, Lawrence. When they ask you to prove that angles are equal, you need to call the one angle X. And now you start moving to it. I'm going to show you the technique. let's first start off. Okay, let's start off with this angle here. Okay. Let's start off with the diagram where they give you an angle, right? So let's draw this circle together. So let's draw that. Take it down with me, guys. Take it down with me. Take it down with me. M is the center. So from there to there, from here to here, from there to there, it's from a past paper, from here to here, from there to there, from here to here. Okay, let's erase here. And let's label it. Okay, A1, A2, D1, D2. They tell you this angle here is 32 degrees. Now you're going to get diagrams with numerical values like this, 32 degrees, 16 degrees. You're going to get diagrams with numerical, and then you're going to get non-numerical where to answer the question that Lawrence asked, if they ask you to prove angles are equal, how do you do it? I'm going to show you the technique. Right. Now you got M. That's 1, M1. This angle here is 128 degrees. This is C1, that's C2, that's C3. And this is B. Right. So they tell in the diagram BD is a diameter. That means M is the center. M is the center of the circle. Now that's very important piece of information, because if M is the center, there's a lot of theorems that deal with the center of the circle. Find D2 with reasons and C1. Find angle D2 and find angle C1 with reasons. Now pay attention. After you've taken it down, put your pens down. Remember, okay, so you want to know for numerical values, this is where you start. Here's it. For numerical diagrams, you start with the known, whichever known you are given. And then start relating other angles or calculating other angles using your mark allocation as a guide. So guys, if it's a 3-mark question, it means it's not if it's a 1-mark or 2-mark question, it means there's a direct link. If it's 3 marks, it means there might be a little, you have to go somewhere else to get there. If it's 4 and 5 marks, you know you've got to make many stops. It's like you are going now from Cape Town to Durban. If it's 1 mark or 2 marks, it's the N1 or N2, straight highway. N4, N5, it means, hey, you know what? We're going from here to PE. We might even we'll go from here to Hermanus. From Hermanus, we'll stop there at Eastern Cape somewhere, PE. From PE, we'll get to Plet. From Plet to Neisner to George. We'll make stops to get there. That's why I'm saying use your mark allocation as a guide. Now, 3 marks. I don't think there's a direct link. Right? I think maybe, watch here, they want D2. Now we can't get to D2 from D1. D1 is 32, we can't get there. But we can clearly see the spearhead shape here. Can you not see it? Can you guys see the spearhead shape? There, 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 and there. So we know exterior angle at center is 2 times the whole angle at circumference. So angle AMC is equal to 2 times angle D1 plus D2. Why? Exterior angle at center is equal to 2 times angle at circumference. So AMC is how many degrees? 128. 128 is equal to 2 times, what's D1? 32 plus D2. What do they want? D2 on its own. So divide by 2, divide by 2. 32 plus D2, that's that. 128 divided by 2 is how much? 64. Angle D2 equals 64 minus 32 is 32. So D2 is also 32 degrees, and you'll get 3 marks for that. Are you guys following me, grade 11s? Are you following me, grade 11s? Right. We now want C1. Now look for relationships here, guys. Let's look for relationships. Now, it's only 2 marks, so it means it's not a heavy relationship. How am I going to get angle C1? How am I going to get angle C1? It's because it's 2 marks. Is it an indirect link or a direct link? Direct. So which is C1 directly related to? Of course. So let me highlight that for you. The bow tie. From there to there to there to here. So angle C1 is directly related to D2 at the circumference, the big bow tie. So all we do now, we answer the question. Let's answer question number 2. Guys, I'm showing you the strategy of getting to your answers. We're doing numerical, and then we're going to do non-numerical just now. Okay. Ooh, okay. Yes. Number 2. Right, angle D2 is equal to 32 degrees. Now, D2 is 32, proven above. Therefore, they want angle C1 is also equal to 32 degrees. Angles in the same segment. Don't go and write bow tie. They'll write WTF. Angles in same segment. What the frog? That's what I meant. Oh, how's your mind is in the gutters. What the fricadelle? Okay. Now let's do another one. Let's do another one. Remember, your paper is not going to be filled. Your paper is not going to be filled with difficult questions. They will build you up to a difficult one. So get your easy stuff right also. So here's another one. Take this one down. Come, guys. Take this one down. CD is a tangent. CD is a tangent. That side is equal to that side. A, that's on the circumference. That's B, D1, D2. This angle here is 4x. This angle here is x minus 30. Right. For 5 marks, solve for x. Question answer. Go for it. What are you given? Look at what you are given and start relating angles. You're given a tangent and a triangle, so you automatically know tan chord. Yes or no? You're given two sides of a triangle equal. What type of a triangle is it? Isosceles. And you also know sum of angles of a triangle add up to how much? I think I just gave you the answer. I think just by identifying what we have, I've just given you the answer. So now you write it out. Write out the logical explanation on how you are going to solve for x, but attach a reason next to it. Attach a reason next to why you're saying each angle is what it is. So what's the first angle you can relate to here? Let's say angle D2 is equal to angle B. Yes or no? D2 equals angle B. What's the reason? Fantastic. Tan chord, which is equal to how much? X minus 30. So that means we know that this angle here, angle B, is X minus 30. Now we need this angle, angle A. But now you can't just say A is equal to X minus 30. You got to prove it to be an isosceles triangle first. So now you're going to say AD is equal to DB, given. Therefore, triangle ADB is isosceles. Therefore, angle A is equal to angle B, which is equal to X minus 30. And you must state the reason. The angles opposite the equal sides of an isosceles triangle are equal. We used to call it in our days, we used to call it, in the dinosaur days, we used to call it base angles. So that's also X minus 30. Right, now we need to solve. The question says solve for X. So now we need an equation. So how are we going to get an equation? We're going to say angle A plus B plus D is equal to 180. Sum of angles of a triangle. What's angle A? X minus 30. What's angle B? X minus 30. What's angle D? 4x is equal to 180. All we do now, bada bing, bada boom, we just solve for x. X plus x is 2x plus 4x is 6x. Minus 30 is minus 60. We'll go on the other side as plus 60. 180 plus 60 is how much? 240. So x is equal to 240 divided by 6, 40 degrees. There we go. We'll get 5 marks for writing out the logical explanation on how you got to your answer, as long as we justified it with reasons. Make sense? Make sense? Guys, you paying attention? I hope so. Okay, let's look at another one. All right. I'll give you one more. I'm going to give you one more numerical one. Then we're going to go into a big one where they're going to say, prove it to be a tangent or prove it to be cyclic, where you have to prove angles to be equal. Okay. So let's do one more. Take this one down. Take this one down. Come, guys. Okay. Sure. This one looks a bit rough. From there to there. From there Just hang on a bit until I get the diagram like sort of 100% correct. I hope I don't make any mistakes in drawing it. Okay. There to there. There to there. From here to here. From there to there. From there to there. There we go. Right, now you can take it down. Drawn perfectly. Right, that's Q. That's P. That's T. That's S. That's O. O1. This whole angle is O1. That's O2. That's O3. This angle here is 96 degrees. That's R. R1. R2. That's U. This is angle S. 1, 2, 3. 1, 2, 3. P1, 2, 3. P1, P2, P3. T1, T2. And T2 is 62 degrees. Here we go. Right, let's start. Asanain, I think you'll have to pull. Can you guys take off that from the screen on the side so that they can see the diagram? Because they can't see the diagram. On that screen that's coming up. No. There on the side. That side thing that's. Okay, just trying to, there we go, that's off, there we go. Right, draw this, guys. The learners here, you guys are disrupting me, please. This set of questions, 3, 6, and 2 is 8, and 3, 11 marks. So question number 1, they want. So they tell you in the diagram, PT and ST are two tangents. So we know we got to, in the story, they're telling you that they are tangents, so we got to use, Sanain, tell them to take that thing off, please. Yeah.
There's something on the screen over here, Sergio. We need your help.
Sergio to the rescue. Right, PT and ST are tangents, so they're already telling you you've got to use a tan chord theorem. T2 is 62. QOS is a diameter. So the only theorem we know about a diameter is a diameter subtends a 90 degrees. We also know that the diameter meets a radius at 90 degrees. So we got two. Because they told us it's a diameter, two theorems apply. Radius OR. So because they're using the word radius, the only theorem that we know what the radius involved is radius is 90 degrees to a tangent. Yes or no? And O2 is 96. Right, that's it. Question number 1, they want the size of angle P3. Question number 2, two other angles equal to P3. Two other angles equal to angle P3. Number 3, angle S3. Number 4, angle R1. Mark allocation, 3, 3, 2, 3. 3, 3, 2, 3. Total marks, 11. Okay, nice question as well. Another nice one here for you guys. This is the last one we're going to do with regard to calculating angles. The ones that we're going to give you after this is where you have to prove it to be, or prove something to be a tangent. Start. Start what you're known. We need to get to P3. Where's P3? There. Right. What angle? Okay, I got it. I got it. And remember, I don't have a memo here. We're doing it as if we are writing this in the June exam. Come, guys, come. What are you not seeing? They give us two tangents meeting at a common point. That's a tangent, that's a tangent. Isn't that side equal to that side? So isn't triangle PTS isosceles? So isn't exterior angle equal to the sum of the interior opposite? So it's 31 and 31 because these two angles are equal. So P3 is 31, that one's 31. 31 plus 31 is 62 outside. Right. So we're going to say PT, we're answering question number 1. PT equals TS, two tangents meeting at a common point. Two tangents meeting at a common point outside the circle are equal in length. Therefore, triangle PTS is isosceles. Therefore, angle P3 equals angle S1, which is equal to 62 degrees. Okay, wait. P3 is equal to S1. We're going to say angles opposite the equal sides. Angles opposite the equal sides of an isosceles triangle. Therefore, P3 is equal to 62 divided by 2. 62 divided by 2. Exterior angle of a triangle is equal to sum of interior opposite. Exterior angle of triangle is equal to sum of the interior opposite angles. But those two angles are equal. That's why we divide it by 2. So it's 31 degrees. So P3 is 31. Let's go and write 31 in there. And S1 is also 31. Fill out as much as you can. The more information you put on the diagram, the easier it is for you for following questions. Right? We all okay? Onliners, are we all okay? I hope you've seen that one. P3 is 31, Lawrence. Well done, Lawrence. Did you get it the same way as I got it, Lawrence? My onliner? I hope you got it the same way. Yes, well done, Lawrence. Well done. Now give me two other angles equal to P3. Now relate P3 to two other angles. Any other angles. Now you know P3 is angle between tangent and chord. So look for tan chord first. Right. This angle P3 is angle between tangent and chord. Is going to equal to angle Q, 31. So I'm answering question now number 2. Right, so let's go. Let's answer question number 2. So now angle Q or PQS, angle PQS, that's a better way because they don't just call it Q. PQS is equal to 31, tan chord theorem. Now, which angle is this related to? Bow tie. Come on, bow tie. R2, 31. So angle R2, therefore, angle R2 is also equal to 31 angles in the same segment. We're all doing it together. No memo. We're relating it. We're doing it as if we're all writing this June paper. I haven't seen this problem. All I did, I opened up the past paper. Here's the question. We put it on the screen. We're tackling it together. S3. S3 is here. Nice. Okay, I got it. Come, find me S3. I want, all right, so which angle is S3 related to? Isn't it related to P1? Now, what is P1 related to? Isn't this 96 here, the spearhead shape? Exterior angle at center is 2 times angle at circumference. So if this angle is 2 times this angle, and this angle is equal to that angle, therefore we can find what S3 is. Common sense. It's not rocket science. Guys, we're in grade 11, we're matriculants. Come. Right. So if this angle here is 96, here's the spearhead shape. So how much is this angle P1 equal to? 96 divided by 2 is how much? 48. Very good. Right. So angle P1, we're answering question number 3. Angle P1 is equal to 48. Why is P1 equal to 48? Angle at center. Exterior angle at center equal to 2 times angle at circumference. Therefore, so if this is 48, therefore S3 is also 48. Angles in the same segment. We're almost there, guys. We're almost there. We're going to do R1. We're going to do one more rider. And that's going to take us right through until the end of the session. We're almost there. You guys spent 2 days. You guys are amazing. We finished a lot of work. We did the whole of functions with application. Process and application. We did the whole of algebra. Process and application. Not just application. We did the whole of trigonometry. Process plus application. Analytics. The whole of analytics. And the whole of Euclidean. Man, we've done 6 months work in 2 days. You guys are amazing to sit through the whole thing. Now you need to go home and learn. Right. R1. R1. Let's do the last one here so that we get our full 11 marks. Where's R1? Here's R1. What do we have there? How do we get to R1? Okay, I got it. We need to get to R1. Onliners, did you guys get it? Well done. Chicken noodle soup say they got it the same way. Well done, well done. Okay, I got it. Let me show you. Let me show you. In this triangle here, boom. There, there, there. Can't I do sum of angles of a triangle? That angle plus that whole angle plus this whole angle adds up to 180 degrees. Yes or no? So angle O2 is 180 minus 96. Adjacent supplementary, angles on a straight line. Remember, we don't write angles on a straight line. We write ADJSUP, adjacent supplementary. It means angles next to each other on a straight line add up to 180. So we use ADJSUP. Right, so O2. 180 minus 96? 84, good. So we got this as 84. Now all the angles, angle O2 plus S3 plus the whole of angle R is equal to 180. Sum of angles of a triangle. Sum of angles of a triangle equal to 180. So what's O2? 84. What's S3? 48. Plus. Now angle R is R1 plus R2. R1 plus R2 we got as 31 is equal to 180. Normal equation, we're solving for R1, got our answer. So 84 plus 48, 84 plus 48 gives me 132 plus R1 plus 31 equals 180. R1 plus 132 plus 31, 163 is equal to 180. Here's your final answer coming up. Therefore, angle R1 equals 180 minus 163, which is equal to how many degrees? 17 degrees. There you go. A problem like this could probably be about 3 to 4 marks. They gave you 3 marks here. You could even get up to 5 because the amount of reasonings that you put. But you're just writing your logical approach as to how you're getting to your answer. Okay. The next question, this is the one that's going to wrap up today. This is the last question for today, guys. Last question for today. 5 and 4 is 9. 9 and 4 is 13. And 2, 15. This is the last question, like what you would see in your Euclidean paper. This one question is worth 15 marks, broken up into 4 parts. Okay? Take the diagram down. It's a bit rough. Here's the last one. Okay, that's the last one for today, guys. You took this down. Can I erase here this reasoning? We at the end, guys. We at the end. Just stay focused for this last 10, 15 minutes to show you how it's done. We're done. The course is done. We finished 2 days. Maths, and more bloody math. Right. Take this one down. Take this one down. Take it down. It's important. Come, guys. Okay, that's your diagram. That's your diagram. That's P, Q, Q1, Q2, Q3, Q4. R, R1, R2, R3. K, 1, 2, 3, 4. 1, 2, 3, 4. L, 1, 2, 3, 4. L, 1, 2, 3, 4. W1, W2, T, S. This line is parallel to that line. Here we go. That's your diagram, guys. That is your diagram. Here are your 4 questions. Right, so they tell you, in the diagram, PQ is a tangent. Okay, PQ is a tangent. PRS is a secant. PRS is a, what does it mean? Look, it just means it's a straight line. A secant cuts at 2 points. A tangent touches at 1 point. But there's nothing more special about a secant. RW cuts SQ at K and cuts QT at L. PS is parallel to QT. RS equal TW. Now, they didn't put it on your diagram, but RS is equal to TW. What? How can it be? Okay, anyway, it's what they say. Who are we to complain? They tell you RS is equal to TW. That's given. Prove. Right, here's your questions. 15 marks coming up. Question number 1, KQ. KQ is a tangent to circle LQW. Question number 2, that angle R1 equal L3. That PRQ KQ, PRKQ is cyclic. Pay attention, guys. RSLQ is not cyclic. This is what you need to prove, all these 4 things. Mark allocation. 5, 4, 4, 2. 5, 4, 4, 2. Okay. We don't have a memo. Nice. Let's try and crack this. This is going to take us to the end of the session, guys. This is going to take, these last 4 questions are going to take us to the end of the session. Now, let's pay attention here. In order to prove that KQ is a tangent to LQW, where's L? LQW, KQ. Now, they're telling you it's a tangent. You got to prove it. So the first thing that you do, LQW, L to circle. Watch here. Read the question carefully. There's a circle around this, and KQ is a tangent. That means it looks like this. It looks like that, like that, like that. Doesn't have to be a perfect circle. However, they're telling you there's a circle. Now, the only way that KQ can be a tangent is if KQ be a tangent. We have to prove tan-chord theorem. We need to prove that Q3. Pay attention here. This is how you interpret these questions. This is how you interpret these questions. Pay attention. In order to prove that this is a tangent, we need to prove that this line here, KQ, is a tangent to a circle LQW. That means draw another. So tangent and a triangle. You have to prove tan chord. So if I can prove that Q3 is equal to W1, game over. Basically, what that question is telling me is to prove that Q3 is equal to W1. If I can do that, my problem is solved. So now we're going to say let Q3 equal to X, because we don't have a value for it. We're doing a non-numerical question. So let's call Q3 equal to X. Let Q3 equal to X. Now, how are we going to prove that W1 is also equal to X? If we do that, therefore KQ is the tangent, tan chord, the converse of the tan chord theorem. The tan chord theorem states angle between tangent and chord is equal to the angle at the alternate segment. But if an angle between a line and a chord is equal to the angle in the alternate segment, therefore that chord must be a tangent. That's the converse. So we are now proving the converse of the tan chord. So let's prove that Q3 is equal to W1. I got no clue. Let's try and get, what is W1 equal to? Okay, if Q3 equals X, let's look at W1. Maybe we could call W1X. Maybe W1's got more relationships. Okay, we know Q3. Okay, I just called let Q3 equal to X. We know these two lines are parallel. So if this is X, S is X. Is there, game over. Game over. See here, Q3 is, we said let Q3 equal to X. Therefore, angle S is equal to X. There we go. And here's the big bow tie. The big bow tie. W1 is equal to X. Here we go. The bow tie. The bow tie angles in the same segment. Therefore, angle W1 equal X. Angles. So this one here is alternate angles. Alternate angles. Because these two lines are parallel. Alternate. The Z shape. W1 equal X, Y, angles in the same segment. Angles in the same segment. There we go, done. Now because, so if Q3 equal X and W1 equal X, therefore, now you must make the statement, KQ is a tangent. Therefore, we now can conclude that KQ is a tangent to LQW, the converse of tan chord theorem. Done. There's your 5 marks, bruh. Lawrence, I hope this one answers your question. I hope this one answers. You asked me that if we have to prove angles to be equal, where do we begin? Now I'm showing you where to begin. Now prove that K1 equal L3. Prove that what? K1 equal to L3. Where is K1? There's K1 equal to L3. Oh my word. All right. Whew. Prove that K1 equals to L3. No, was it K1 or R1? R1, sorry, I'm thinking about that. So that's wrong. So R1. So we need to prove R1. So let's go here. We need to prove that R1 is equal to L3. Okay. Still doesn't make sense, but anyway, let's still do it. We'll find it. We'll find it. Find it, we will. Okay. Let's go. R1. What is R1 equal to? We want it to equal to L3. Nah? L3 L3. Okay, wait. Okay, so we know Q1. So now this is a tangent as well to the bigger circle. I'm just showing you something here. I'm just filling in as much information as I can from what I can see. So if this is a tangent, PQ is a tangent. PQ is a tangent. So we also know angle between, so we know if that is angle X, then we know that angle Q1 is also equal to X tan chord theorem. Not that, I don't know whether it's going to help us or it's not going to help us. It's immaterial. Can we find out what K2 equals to? You see R1, no. Let's see what is angle L3. Again, these two lines are parallel, right? Pay attention. So we got a line like that, we got a line like this, and then we got this line coming down that way. We got, where is it? We got that line coming down that way. This is actually angle L3. So L3 here, angle L3, I'm just going to highlight it here. L3, because that line is parallel to that line, L3 is equal to R3. Alternate angles. That's R3. So those two angles are equal, right? Alternate. Now, can I prove that R3 is equal to R1? R3 is equal to this whole angle here. That is equal to that. That is equal to that. R1 is equal to that plus that. R1 equal to L3. It's worth 4 marks. R1 equal to L3. Okay, L3 is also equal to L1. Vertically opposite. But what is R1? How do we get R1 into the triangle? R1 is completely outside the triangle. Did they tell? Okay. Did they tell us SQ is a diameter? I just want to check out something. Did they tell us that SQ is a diameter? No, they just said PQ is a tangent, PRS is a secant, RW cuts that and cuts that. PS is parallel to QT, RS equal TW. Prove that angle R1 equal L3. God! R1 equal to L3. Something, something, something. What is R1 equal to? Tangent, that's not a diameter. And chord. We know TW is equal to RS, so we know that Q4. Wait. No, but Q4 is equal to Q2. But that's not going to help us Because if this angle is y, R1 equal to L3. If I called L3 y, if I call L3 y, then L1 equals to what? Ah, done. No, I got R3. I didn't get R1. Shucks. Okay, if this one is y, that one is y, these two lines, so I got that as y. Okay, so let's say I call this y. Let's say I call L3y. Right, so I'm now going to say let angle L3 equal to y. Therefore, L1 equals to y, vertically opposite. Therefore, angle L1 equals to y, vertically opposite. And now we know that these two lines are parallel, so correspondingly equal, R3 is also equal to y, corresponding. But now we need to get to R1. We now need to get to R1. R1 is x plus k2. Ah, I got it. I got it. Got nothing to do with the y's. Hey, I found it. I got it. I got it. I got it.
Why so much drama, Khota? Easy,
Bruh,
man.
if you only know how you got to apply your mind here. R1, watch here. R1, angle R1 is equal to S plus Q2. S plus Q2. Why? Exterior angle of a triangle is equal to sum of interior. Yes or no? Exterior angle of triangle is equal to sum of the interior opposite. So angle R1 is equal to what is S? X plus Q2. Right, good. X plus Q2. So I'm putting a tick by Q2. X plus Q2. Let's look at L3. Watch here, watch here, watch here, because that's what they want. They want R1 equal to L3. L3 is equal to X plus Q4. There's a triangle here. Watch here, watch here, watch here, watch here. L3 is equal to W1 plus Q4, X plus Q4. So there's a X, there's a X. Is Q2 equal to Q4? Is Q2 equal to Q4? Yes. Why? Equal chords subtend equal angles. Equal chords subtend equal angles. But, so that is equal to that. But Q2 is equal to Q4 because equal chords subtend equal angles at the circumference. Therefore, R1 equals L3. Yay! You leave this one for last in your paper. If you get it, you get it. You don't get it, tough cookie. But the rest of your paper, as long as you know you got 100% for it. Are you guys with me? Okay, that one made us sweat a little. PRKQ is cyclic. Hey, we got 2 minutes left. Prove that P, where's P? P, R, K, Q. Prove that this is cyclic. R3, Can we prove that the exterior angle is equal to the interior opposite? Can we prove that R3 is equal to Q1 plus Q2, the tick, X plus tick? Can I prove that this R3 is equal to this whole angle here? If I can prove that R3 is equal to this, therefore this is cyclic. Exterior angle of a cyclic quad equal to interior opposite. So that's my game plan. My game plan is to prove that R3 is X plus tick. Will R3 equal to X plus tick? Then problem is solved. Right, we know Q1 is X. We know Q2 is a tick. We know Q2 is equal to Q4, which is tick. Equal chord, subtend, equal angles. We know this angle here is, so can I prove that that K3 is a tick? If I can, no, because R3 must equal to X plus tick. Oh, yes, it is. Yes, watch here. Watch. I found it. Yay. Check here. The big, watch here. Okay, let me see if I can do it in a darker, what color can we do? Let's do it in green. Watch this. Watch this. I need to prove that R3 is X plus tick. So watch. Here's the bow tie. Check this bow tie. From there to there, there to there, here to here, there to there. Isn't Q3 plus Q4 X plus tick? Isn't Q3 plus Q4 X plus tick? Yes or no? Angle R3 is equal to Q3 plus Q4. Q3 plus Q4, which is X plus tick. But angle Q1 plus Q2 is also X plus tick. But Q1 plus Q2 is also equal to X plus tick. Therefore, R3 is equal to PQK. PQK. Therefore, PQKR. PQKR is cyclic. Why? The exterior angle equal to interior opposite. Exterior angle of cyclic quad equal to interior opposite angle. There we go. So that's X plus tick. X plus tick, X. You could have even called it Y. You could have said Q2 is Y, Q4 is Y. So Q is X plus Y. That's X plus Y. That's X plus Y. Exterior angle equal to your interior opposite. Yo, we got 1 minute left. R, S, L, Q, R, S. Where the hell is S? S, L, Q is not cyclic. It can't be cyclic because L3 is Y. S is X. The angles are not the same. Therefore, angles in the same segment are not equal. Therefore, it is not cyclic. So let's write that out for you. They want you to prove that RSLQ not cyclic. Let's draw it. RSLQ. Prove that it's not cyclic. That angle is Y. That angle is S. Angle S equal X. Angle L3 equal Y. Therefore, RSLQ not cyclic because angles in the same segment of RSLQ are not equal. Therefore, not cyclic. And there we go. We've come to the end of our 2-day program. Boys and girls, I think you all deserve a fantastic round of applause. You guys are amazing. Thank you, SP learners and all the learners that came from all the different schools here in Cape Town. Thank you guys for attending our 2-day June exam intensive prep. I hope you guys have learned a lot. I hope you guys take all what we've showed you over the past 2 days. You go and practice with it. You understand it and you apply it. We look forward to seeing you guys at in the next term, before term 3, and at the end of the year. Huh? Okay,
Yes,
thank you guys. Onliners, thank you so much.
so that concludes the Awqaf SA Grade 11 Maths Workshop. You all deserve a round of applause. How's a round of applause there, guys? And for Mr. Khota, a special round of applause for him. So, Mr. Khota, I really enjoyed the session. So, for all of you listening out there, we will be having a session in August. Yes, in August, we'll be having another mega session here. We'd like to have all of the learners online attend that. And the last one for the year
will be the last. So we will be having one in August before your September exams or your September prep. And the final one will be in October. October before your November exam. And that's a 2-day course. And we'll be doing the whole of paper 1, the whole of paper 2, only pass paper application. Boys and girls, you guys have been absolutely amazing. Thank you so much.
we appreciate your effort. Hey, it's Saturday, Sunday.
Yes.
And they are here.
And they are here.
So you deserve a round of applause, special round of applause for you guys.
Thank you so much.
So that's it from us. We'd like to thank all of the educators here at SP, the principal, Mr. Charles, what was our maths teacher, Melissa, was also here. Really fantastic people. Concluding remarks, Khota?
Guys, you guys have been absolutely amazing, especially our onliners. You guys have been totally engaged, onliners and on-siters. You guys managed to pull 2 full days of mathematics. I know you guys were seeing stars at a certain point, but as long as you've understood what we've done, you go home, you practice, you apply. Good luck, God bless, and inshallah, may you guys all do well in your exams.
See you for the next one. That's us. Thank you. Assalamu alaikum.